Program. Okay, a very, very good morning, everyone. Can I just check you can hear me? Because it's always a good start if you can. Somebody give me a thumbs up or say yes. Fantastic, see a thumbs up. Brilliant. Okay, so welcome this morning to week 2 of the HSMA training. So last week was a kind of general introduction to the world of operational research and data science on the Tuesday, and then obviously we talked a little bit about the principles of programming on Tuesday afternoon, and then on Thursday morning we had a look at the software that you're going to be using for most of this course to get you familiar with that, because from today onwards you're actually going to be doing some hands-on coding. So this all starts really this month with teaching you Python. Now, when we say teach you Python, there's no way we can teach you everything in Python. That would be too monumental a task, and actually wouldn't be the right thing to do anyway. So the approach that we take is, for the next 3 weeks, we're going to teach you some key stuff in Python to allow you to start sort of coding the fundamentals, etc., and be able to understand the basics of how to write and read Python code. As we go through the course, you will also see more and more examples of things that we haven't shown you yet in Python that we will teach you as we go along. So, for example, in the SymPy training, come on to that. SymPy is based around something called a generator function. So we will cover generator functions when we talk about SymPy. Similarly, there'll be some stuff in the machine learning that will come up. So there'll be little bits that will come up throughout. But the basic idea of these next 3 weeks is to get you being able to code programs in Python. By the end of today, you will be writing, quite literally writing programs in Python. You can have lots of hands-on experience today. So there's quite a bit to go through today, but you'll have lots of chance in your groups to work through and have a go at coding yourselves. So there'll be lots of opportunity to practice. Now, a key thing with learning any programming language is that it requires practice, and absolutely I mean, really, for learning any language, you try to learn French or another language, you need to practice it. And if you don't, you will find you'll get rusty very quickly. It's fundamentally important when you're learning any language that you are practicing and using it. So get into the habit of practicing little bits of code, even if it's 5-10 minutes a day, or every few days doing a little half an hour of coding or something, just to practice. Now, to that end, this year we have introduced optional coding club sessions, the first one of which will be next week, so a week tomorrow. There'll be the first coding club. They're little optional 2-hour sessions. You're entirely welcome to come along to those. And the idea is that there will be a task to do in groups, depending on numbers. If it's just a relatively small number of you come along, then we'll just do it as one big group. And you'll be tasked with doing something using your new coding skills. And the thing you'll be asked to do, hopefully, will be quite fun. So you'll get the opportunity to be quite creative, so that it's not heavily prescribed what you have to do. But you'll be told to create something that follows these guidelines and write something in Python. So it'll be a good, and the whole reason we're doing that is precisely for what I've just talked about. The practicing this code, particularly if you're new to programming itself, is fundamentally important. So it'll allow you to sort of flex your coding muscles and get used to coding, because this stuff, if you're new to coding, at first it might seem overwhelming. Okay, I promise you, if you put in the time, you will get used to this, and hopefully you will enjoy it. If you don't enjoy it and you find you absolutely hate coding, that's fine as well. Not everybody's built for coding. Not everybody should be built for coding. So that's a fine conclusion. We've had people on the course that have, after a couple of months, just realised I don't like this. This isn't for me. and that's okay too. But hopefully, from what I've read of your applications, that most of you certainly will enjoy what we're going to do. But as I say, don't worry if you find it overwhelming at first, because it's like learning a new language. It's going to seem all very strange and mysterious at first, but hopefully the way we'll guide you through this will gradually make sense. So I see Elliot's here. I'm just going to make Elliot a co-host. Elliot, if you can just as I flip through the slides now, if you can just let anybody in. I think we've got 91, so we've got most, but there will still be a few pouring in. Okay, let's make a start. So why are we teaching you Python? Let's start with that question. Python is now the most widely used programming language in the world. Okay, and there's a very good reason for that, and it's because of its accessibility, and also because of some of the stuff that we talked about on Thursday in terms of it's very good for scientific computing. And with the advent of accessible AI and neural networks and data science becoming a bigger phenomenon, then Python is the natural home for that. So most people who do data science do so in Python. You can do some of this stuff in R, but most people do it in Python. Okay, there are other languages that are popular for other things like Java, etc. Java is, well, I was going to say it's great. I don't really like Java. I was taught Java at an undergrad level. I think it's a horrible language personally, but things like that are good if you're building big enterprise systems. You are not building big enterprise systems. To give you an example, Java, unless it's changed from when I did it many years ago, used to take 3 to 4 lines of code just to get a piece of input from the user, because it's not designed for stuff like that. It's designed for building big stuff. Whereas Python, you can do things much more quickly and much more elegantly, and it's a little bit more rough around the edges because of that. And we'll see some examples this morning of how it's a little bit looser with things, but that's actually to its advantage for the kind of stuff that we'll be doing. It's also named after Monty Python, the classic comedy troupe, which is another great thing. I think that's a nice little touch. And Python also has lots and lots, because it's so popular. It's got lots of extensive libraries of code that people have written already, so we don't have to reinvent the wheel. The things that we may want to be able to do ourselves, people have generally written other stuff that we can then import and adapt as we need it. And because it's so popular, there are huge amounts of this stuff out there. And as I said on Thursday, we were talking about that it allows us to interact. Python allows us to interact and get quick results and build and test iteratively. So we looked at the IPython console and saw how we could interact with things, interact with our code and probe it and sort of prod it and test bits. That's really important for scientific computing. Okay, so there's a tradition in computer science. There are many traditions in computer science, but this is probably one of the better known. That the first program that anyone should write in a programming language is one that writes the words "Hello World" to the screen. Now, it doesn't sound particularly exciting. As I say, back in my day, when I was first coding back in the mid-80s, getting anything to display on my television set that I had created was fundamentally exciting. That's pretty cool. And that tradition has carried through. So it's a tradition that we write whenever we're learning a new program language. The first thing we do is get it to put the words "Hello World" on the screen. Now, in order to do this in Python, we use what's called the print function. Print is nothing to do with your printer. It's to do with putting text information onto the screen. So we use the print function, and we use the brackets here. Basically, this is the standard function notation. We have the name of the function, and remember from our talk of functions last week, we said a function has a name, and then it has possibly some inputs and it possibly some outputs. So with the print function, obviously the thing that we need to pass into it is something to print, some text to print onto the screen. Okay, so that will be our input. So what we do in Python is we can use print and use brackets and then put "Hello World." So if I go into Spider at this point, I'll switch over to Spider here, and I'm going to type print Hello world. I'm even going to put an exclamation mark just to be very fancy there. That simple command, if I now run that program, we can see in our IPython console over here, it's printed the words hello world. Okay. I promise you it gets a bit more exciting than this, but we have to start somewhere. And this is indeed where we start. And again, we could have written that, as we saw when we did this last week, we could have written that in the interactive console and it would have immediately executed. Remember, the interactive Python console allows us to, rather than in the editor pane where we write a set of instructions that will then tell it when to run and run through those instructions, we could have done that in the interactive Python console and it would have immediately executed that instruction. So rather than writing a program, we would have been writing an immediate instruction that we wanted it to carry out. Now, we can now know how to print to the screen. We talked extensively last week in our principles of programming about variables, and we said that variables are how we want the computer to remember certain things. Okay, and essentially a variable stores some information and it has a label. It's a bit like a box, and it has a label that indicates what information is stored within it. Now, in a lot of programming languages, the way in which we set up a variable is we declare it. And that when we declare a variable, that means we say, I want a new variable and I want to call it this. And it's of this type. And remember, we talked about different types of variables. So there'll be variables that hold numbers, whole numbers. There'll be variables that hold decimal numbers, floats. There'll be variables that hold text information, strings, etc. So there's lots of different types of variable. So in a lot of programming languages, you say, I want a variable, I want to call it age, and it's an integer. Okay, and then if you try to put anything other than an integer into that variable, it'll throw up an error and say, sorry, you said that was an integer. I'm only going to store integer information. However, Python is not like that. Python, the variables in Python are what we call dynamic. Okay, so we don't actually need, when we declare a variable, we just give it a name. That's it, and maybe an initial value. But we don't actually say what kind of type of information we want in there. So we assign a value to a name that creates the variable, and the type will automatically be set based on whatever value goes in there. Okay, so in Python, we assign variable values using the assignment operator. Now, this is a bit confusing if you've not done coding before, because we use the equal sign. Now, something very important in programming is that equals in programming does not mean equals mathematically. Okay, it doesn't mean that equals that. It means assign this value into this thing. Okay, so in this example here, age equals 52 means create a variable called age, or if we've already got a variable called age, update the value of age and give it a value of 52. So put 52 into the box called age. Put the string Bob into the variable name. Okay, so equals is an assignment operator. I'll show you in a bit how you actually say, because you will also need to say, are two things equal? And there's a different way you do that. Okay, so equals, it means assignment. Okay, and a lot of programming languages use that notation, apart from R, which we'll learn about in 6 months' time, which uses weird arrows, and some of you will be aware of that. So here we've got an integer of 52 going into age, and a string that says the word Bob going into name. Now with Python, oh no, I don't say that here. So with Python, because the variables are dynamic, if I then had a second line of code that then said age equals Bob, it would change the value of age to Bob, and Bob would now be a string type variable. It would just automatically change it and go, oh, well, I guess you must want it to be a string now. Now, that's really useful when we're trying to code quickly and develop up very quick applications, which is what Python's about. The only downside of that is that if you're not careful, you can accidentally do things that more restrictive, what we call strongly typed languages, don't allow you to do. So if you don't mean to put a string into this variable value because it's supposed to be an integer, Python will let you do it. It will just say, okay, yeah, it's fine. Age is now Bob, whatever you say. So another strongly typed language where you have to declare it's an integer would then throw up an error and go, hey, hang on, you said that was going to be an integer. I've got a string in here. I reckon something's going wrong in your code because you've dumped a string where an integer should be. So it does have downsides. You have to be a little bit mindful of that, but it is the price we pay for quickness and convenience. But just be aware of that. Now, we talked about variable names. In programming languages, a space will indicate a separation between entities, so a separation between instructions, values, etc. So if we wanted to give say a variable a name that had multiple words, and we will want to do that quite often because sometimes name won't be good enough. We may have different types of name. We may need to call it username or user age to distinguish between something else. So, or for example, we might have patient age, patient name, doctor age, doctor name, etc. So we usually need more than one word for a lot of things. Now we can't put spaces in because if we put a space, then Python will think it's something else. It thinks it's a separate thing. So there's basically two ways in which we can, two conventions that are used in order to put multiple words as the name of something like a variable. Okay, one of which is camel case, and the other is snake case. So camel case, what we do is we start, the first letter is lowercase. That's fundamentally important. Uppercase, you start uppercase, a variable name must always start lowercase. Uppercase starting letters are reserved for things like classes, as you'll come on to. So you should never start with with an uppercase letter unless it's something like a class. There's specific situations where you're supposed to use capital letters. Okay, so you have to start with a lowercase, but you can put capital letters elsewhere. And so camel case uses that, and it says, okay, well, I'll have the first word starting with lowercase because I have to, but then for each new word, I'll start with a capital letter, and that will distinguish it as being a new word. Okay. I used to use camel case quite a lot. I don't now. And actually, the better approach, the more Pythonic approach for Python, and it is the preferred method for Python, is to use what we call snake case. Snake case is we have all of our words, but rather than spaces in between them, we just use an underscore. Okay, and that then allows it. I think that's much easier to read personally. It's down to you, however you want to do it. But the convention for Python is to use snake case, and you'll see most people would use snake case for Python. So that's what we'll be using in this course, but you may see examples of camel case being used. Okay, so we talked about variable types as well as names, and let's just remind ourselves of some of the main variable types, not all of them because there's lots, and see how we'd use them in Python. So remember last week we talked about different types of number variables. So we've got things like called integers. These are whole numbers. Okay, they don't take as much memory because they're just whole numbers. We haven't got the decimal point to worry about and all the numbers that come after it. So in Python, these are referred to as ints. So an int is an integer number. Okay. Remember, we don't have to declare it as an int, but that's what Python will store it as if we give it an integer. We've also got floating point numbers, which are, remember, numbers with a decimal place. That's the floating point. A float stores numbers up to 15 decimal places. There are other formats that allow you to, if you need greater precision than 15 decimal places, there are other variable types that allow you to do that use more memory. I would strongly advise you will not need anything like that for the kind of stuff you will be doing. You are not doing very high precision stuff like that. In fact, if you remember when we talked last week about modeling and being careful about how people interpret results, one approach to making sure that people understand this isn't highly precise when you're building a model is to round your results, because if you say give a prediction of an average of waiting time of 33.7 minutes, that kind of indicates that it's very precise, the prediction it's making. In fact, it's no such thing. Okay, so be careful how you use very, very precise numbers when you're doing modeling, but you will need integers and you will need floats. Both of those things you will need for whatever you're doing in this course. We've also got strings. So strings are basically, remember, just sequences of characters, and they are denoted using either double quotation marks or single quotation marks. In Python, they're completely interchangeable. You can use either. It doesn't matter. You have to be consistent and use, if you start with a double quotation, you have to end with one, but you can have either. So this string apple is equally valid with the double quotation marks as Dan is the best teacher with single quotation marks. These are both valid ways of writing a string. Okay, so in some languages that matters. There is a difference. In Python, it doesn't. You can use whatever you prefer. I tend to use double quotation marks for strings and use single quotation marks for some other text information that you'll see later. But it's entirely up to you. You can do that however you like. We also talked about, last week we talked about lists. We said that lists are ordered sequences of things. So we store a number of data values within a list, and the order matters. So here is how we set up a list within Python. We use square bracket notation. Okay, so that indicates it's a list, and Python will recognize it as such. So if I wanted to set up a list with the values 1, 5, 3, Matthew, and true, remember these are integers, that's a string, and that's a Boolean. Then all we do is we give the variable name as normal. We use the assignment operator equals, and then we use square brackets, and we separate each value using a comma. So that becomes a list called my list, and it's got these values in this order. Okay, that matters for a list. Then we've got sets. So a set, remember, is an unordered sequence. It's a bit like a list, but the order doesn't matter. But the reason the order doesn't matter is because it can only contain unique items. So you can't have duplicate values in a set. You won't use sets quite so much, but they will crop up every now and then. But the way we do that is exactly the same as the list, except we use curly brackets rather than square brackets. And then Python knows, oh, okay, you want that as a set. So then if you try to add another value that was already in there, like another value of 2, Python wouldn't let you, because it's a set, and it knows it's a set because you've told it here are some curly brackets. Python says, okay, it's a set, and it won't allow you to do that. Then we've got dictionaries. Dictionaries, I did mention last week, you will use dictionaries quite a lot. So dictionaries also are unordered. The order doesn't matter. But the reason the order doesn't matter for a dictionary is because they're essentially key value pairs. You use a dictionary when you say, I want a kind of lookup value, and against that, I want a value stored against it. So here's an example dictionary. I've got a lookup value of name, and the value I want to store against that is Dan. So if I look up name, I want you to return Dan. If I look up age, it'd be lovely to return 39, even though that's slightly out of date now. Okay, so again, with a dictionary, we notate it with curly brackets in the same way as a set, but it identifies it's a dictionary because we use these key value pairs. So we have the key here, followed by a colon, followed by the value, and then each key value pair is separated by a comma. Okay, so typically you'd have a kind of string lookup value, and then whatever you like for value. It could be a string, could be an integer, or it could be anything. And it's quite important to say with any of these what we call iterable objects, things like lists, sets, dictionaries, etc., where you can iterate over them and look up each value. Excuse me. With anything like this, you can have pretty much anything, what we call a Python object within them. So you can have a list that contains lists. You can have a list of lists, and you can have a list of lists of lists of lists. And you'll see some examples of that within the course, although you have to be careful about nesting down too much. But a list is itself a Python object. You could have a list of dictionaries. You could have a dictionary where the lookup values are lists. Okay, so you can put pretty much anything. Generally speaking, in these kinds of things, for you, the stuff you'll be doing, you'll be putting in strings and integers and floats, and sometimes objects. When we come onto the object-oriented stuff, you'll see examples of that. We've also got these things called tuples. So tuples, like lists, the order matters. So it's a bit like a list. But the key difference between a tuple and a list is that a tuple is immutable. That means that once you've created it, it cannot be changed. You can't add extra elements. You can't take anything away. Okay. They're not particularly useful for a lot of things, except for a very small subset of things that they tend to be used for. But you will encounter them every now and then. And the tuples are denoted using the normal normal round brackets here. Okay, so that's a tuple, but unlike a list, you can't change it once it's been set up. And then we've got booleans, which are, remember, they're just a value which holds a variable which holds a value of either true or false. We use them a lot in conditional logic. So we say it's true or it's false. And we do that in Python just by using these two are keywords. These are reserved keywords. You can't call anything else true with a capital T or false with a capital F. They are reserved for values true and false for booleans. Okay. Now, there's a really nice feature in newer versions of Python, anything from 3.6 onwards, which hopefully you've all got, called F strings. Now, an F string is short for formatted string literal, which isn't a very friendly name. So we call them F strings, okay? Now, these are basically strings where we can include formatting within the string itself to define where we want a piece of dynamic text. So usually we'll use something like that when we want to insert the value of a variable into a string. So we want to print out a message, but put in whatever variable value. So maybe we want to write the string, her name is, and then we want to put in whatever value is stored in the name variable. Okay, and an F string allows us to do that really easily and far more elegantly than the old method, which I'll also show you because you will see it. But with an F string, all we need to do is we put a little lowercase f in front, directly in front of the either double or single quotation marks, okay, at the start of our string. And then within the string, where we want to put a variable name to say, actually, don't hard code a piece of text here. I want you to draw in whatever's in that variable value. Then we just use curly brackets in the string. And because it's an F string, Python will go, oh, right, okay. So here, it won't print to the message, the patient lives in hometown. It'll print the patient lives in, and then Python will go off and look inside the variable hometown, and it'll put in here whatever it finds in hometown. So if the hometown is Lou in Cornwall, which is my hometown, that's what it'll put. Okay. So rather than hard coding it, it allows you to very easily put in a variable value. They're really neat. So we could amend our hello world program, and instead of saying hello to the world, we could make it more personal and get it to say hello to me in terms of my storing a variable called name. So let me just switch out and do that. So if I go here, I'm going to change this now. Let's get rid of that. So I'm going to put my name. I'm going to create a variable called my name. I'm going to say put in the value of Dan. And then I'm going to put a print message here. And I'm going to put a little character F to indicate this could be an F string. Then I'm going to start my quotation marks. You can always tell it's done it correctly because in Spider, this will change to the same color, usually green. Depends on your theme as your string. And I'll put hello. But instead of writing Dan here, I'm going to put hello, open my curly brackets, and put hello, my name. If I run that, you can see it says hello, Dan. I can then just change the variable value. So if I put Elliot, run that again, it now says hello, Elliot. The print statement hasn't changed, the variable value has. Okay, so it's really neat for being able to do stuff like that where you want to print, and you'll want to do that a lot, where you're printing out output messages. But the stuff you're outputting, like, for example, a result from a model, is going to be stored in a variable value. You can't hard code that. You don't when you at the time that you're writing your computer program, you don't know what the result is going to be of the model, and it'll change every time. So you want to print out the value of a variable rather than something you hard code. But you can do more than just put in variable names in the curly brackets in F strings. And in fact, you can put any instruction that could be interpreted as a string. So for example, things like numbers. So you can even put in stuff like this. The answer is, and then in curly brackets, put 2 plus 2. Okay, now that's an integer. And so Python will actually, in an F string, it'll perform that calculation of 2 plus 2. That will result in an integer, but an integer you can interpret as a string. So Python knows how to turn an integer into a string. Okay, so we can just print the value 4. And you see here it does that. So you can put little calculations in there. We could have here a really long floating point number. We can actually get it to round within our curly brackets within the F string. So if I put in my curly brackets, I put in the name of the variable. If I put then a colon after that name, still within the curly brackets, and then a decimal point, and then if I put here 2F, that means this is a floating point number that I want to give you, and I want it to a precision of 2 decimal places. So then in output 4.68 here rather than 4.67823, etc. So if you don't put that, if you just put my float, it would print out the whole thing up to 15 decimal places, which is what a float stores. Okay, so this is really handy because you'll want to round things. Now it's not actually rounding the number. The value stored in my float is still the raw number, but to the user, they're just seeing the rounded value, and that's usually quite helpful because you probably want to keep the raw number for other calculations. But you can, if you needed to report that, but the reporting to the user, they probably only need to see a rounded version of that. So you can do that really easily. If I change that to 1F, that will be to 1 decimal place, 5F, 5 decimal places, etc. Also, now remember I said last week on Thursday about this line, this 80 character limit line, that you should never ever go over that line, even though it will let you, because it's very bad practice. And I said there's different ways in which you can do that. So you may be thinking to yourself, well, hang on, Dan, what if I want to write a fairly long message and it now goes over the line? What am I supposed to do then? Well, you can do it really easily with F strings. You just put in your print statement. In fact, with any string, it doesn't have to be an F string. You can put a print statement, and you can have more than one input into a print statement. So you can have a string of text here, and then if you need to go onto a new line in your code, you can just separate them by commas. Okay, so that keeps your code elegant, but all of this will actually be written on the same line when it's printed out, and you can see that down here. Also, just point out, it'll automatically put in a space between each one, so you don't need to do that. So if you want to write long strings that, if you wrote them here, would go over your coding line, your 80 character limit, then just separate them by commas and then close the bracket when you're finished, and it'll interpret that as one line of code. So it keeps it elegant. Now I said I'd show you the old method because for earlier versions of Python, you couldn't use F strings. And you will still see this floating around. There'll even be bits of the training that are from older bits of code that you'll see this in. Most of it I've converted to F strings, but you will still see bits floating around. And importantly, when you go out into the wild, you'll see people still doing this. It's important you know it. I would advise you just use the F string method yourselves, because it's much more elegant. But the old way of doing things, and you'll see why F strings are so much nicer, was that if you needed to put hello my name, you'd use a normal print statement, and then you'd separate by comma a string value here using the quotation marks, and then a variable value here that you just give as the variable name outside of the string. And you can see that gets very complicated quite quickly. Yeah, I can see a hands up.
Hi. When you had combined the F strings, you didn't include a separator character, and the strings didn't have spaces at the end of them. So will Python insert spaces between the f strings, or would you have to print them as you want them formatted?
So by default, Python, when you have on multiple lines, it'll automatically, or if you've got them as separate elements, it'll automatically insert a space. So you can use the separator operator if you don't want to do that. But with an F string, the only reason you'd need to have separate elements within a print statement is if you're splitting it over multiple lines. I personally, I find it easier just to forget about the space and know that Python will put it in. But yes, you can still use this sep operator here, and that if you put the open and close the quotation marks as the value for that, it'll basically say don't put in any spaces, because I've put them in myself.
Okay, super, thanks.
So that was basically the old way of doing things, and you can see it gets more complicated if you've got just a couple variables in there. You've got print, open quotes, happy birthday, space, close quotes, comma, my name. It's not very elegant. Okay, so the F strings are much nicer, but you will see this on a lot of code, because that was the way of doing things for many years. Okay. But hopefully you'll see the F strings are nicer for this kind of stuff. Now, what we also need to do with Python is to get the user at various points to input information, to provide some information to the program to allow it to do something. Now, I said in Java, it used to be an absolute nightmare getting inputs from the user. In Python, it's really easy. Single command that will let you do this. We simply tell Python we need an input. We give it any message that we might want to display to the user to prompt them for that input, and we give the name of the variable where we're going to store whatever the user inputs. Okay, so let's have a look at an example. So if I wanted to ask how old the user is, so I can store it in a variable called age. Then I'd say age equals. Remember, equals is an assignment operator. So what I'm saying here is, in my variable age, which if it doesn't exist, create it. If it does exist, overwrite whatever's stored in age. In the variable age, store this value. And rather than putting a value like 41, I'm going to put in here an input statement. So I say whatever it gets stored in here is whatever the user now inputs. So this input statement will prompt Python to ask the user for this value. Okay, so I use the input command, I open my brackets, and the input I give to the input command is the message that I want to display to the user. So I'm going to put how old are you is my little message, and because I'm nice and friendly, I'm going to put a little space and a colon, and it'll look all neat on the screen, but you don't have to do that. So I'm saying how old are you? When I run that, the Python will stop and it'll ask a user how old they are, and it will then store that value in age. Now, if I were to do that for this piece of code, for something like age, there might be a problem with the way I'm doing this. Does anybody know what that might be?
The user might respond with something that isn't an integer.
Yeah, I mean, they may, although of course Python will then just will deal with that. It will take that. But you're on the right line, so there's an even more fundamental issue.
Something to do with the fact it's a string and not a number.
Yes, exactly that. So basically what's happening, Python, when it puts in that input, it then gives a prompt for the user to type something in. The thing that it reads in is a string. Okay, so it's a piece of text. Even if it's a number, it'll read that in as a string. It's some sequence of characters. So if I put in 41, it's not reading that in as the number 41. Python reads it as the string, which is combined of the two characters 4 and 1, which is not the same as the number 41. It looks it, but it's different. Okay. Now, sometimes when you read something in from the user, you want it to be a string. That's fine. That's what it'll be by default. But it's something like age, you're probably going to want to deal with it as a number. Okay, you may not, but likely you're going to want to store it as a number in your code. So to do that, we can use something called casting. Okay, now casting is, I love the way it sounds so wizardy, because it kind of is. So basically it says, you variable that are a string, I'm going to cast you, you're now going to turn into an integer. Okay, that's what casting does. Turns a variable from one type into another. Now Python is very clever, and so if you type in 41, it'll read that in as a string. You can then cast that string as an integer, and it'll say, oh yeah, I can see that's the number 41, it's now 41. But remember, it can't do the impossible. So if you were to write the word cat and then told it to convert cat to an integer, it would throw up an error. It would say, well, I can't interpret cat as an integer. What are you talking about? Well, it might be a bit more polite than that. So it will be clever, but it can't perform miracles. So just bear that in mind. So the way we cast a variable from one type into another is we simply give the type of variable that we want to turn it into, and then use brackets, and then put inside those brackets the name of the variable that we're casting. So here I've got my age, input how old are you, this will read in as a string. So at this point age is now a string, so I put in 41, it's now the string, which is composed of the characters 4 and 1. But then on this next line I'm going to convert that into an integer. So I use int, remember that's what we call integers in Python, open my brackets, and I give the variable age. So it will convert this string age into an integer. We could do all that on the same line as well if we wanted to be even more elegant. We could say, we could wrap it. So we could use the input command here, and before it gets stored as an age, we can wrap that entire input command in an integer cast itself. So it'll read it'll do this first, it'll do whatever's inside here, it'll get the input from the user, and then it'll use that, the output of that will then be cast as an integer. So it's doing the same thing, it's just here it's doing it in one step rather than up here where it's reading in a string and then converting it into an integer. Yes, sorry, there was a hand up.
Sorry, I was just going to ask, does that last, if you do the int on the same line, does that act as an input mask for the user, so that then they know that it would error to the user if they try to type it out in letters rather than into 41 as an int?
It depends how you've set up your code. So by default, the input command accepts any string. So it will allow them to type anything they like. But usually at that point, and we'll come on to exception handling next week, and we'll see some examples of this, you'll probably want to capture errors where you've said how old are you, you need them to input a number because you're going to convert it into an integer. If they don't and they type the word cat, obviously your program is going to collapse because if you then try and convert it to an integer, Python will just go no error and it will stop. So when we come on to exception handling next week, you'll see how you deal with that, where you then say you can then prompt the user, for example, and say no, I need something as a number, stop typing the word cat or whatever you might want to do. So we'll see examples of that. Yeah, sorry, another question.
Yes, I wanted to ask if what if somebody puts a float into it? Will it convert it to an int by rounding or something like that?
No, so it does convert it to an int. I believe it doesn't round, so it just chops off the decimal place. So there's no, I don't believe, unless that's changed, pretty sure it just removes the floating point. So yeah, you need to be a bit careful with that as well, because it will just say, in fact, let's try it. This is a good, this is a good tip. If ever you're unsure of something in Python, this is the beauty of Python. Let's just try it. Okay, so let's have a value called a, and I'm going to put in 4.67. Okay, so if I type a, I can see the value is 4.67. I'm going to store in a second value called b an integer value of a. Let's see what's stored in b. Yeah, 4. So no, it doesn't round. So it is just chopping off the decimal place. So be aware of that. You'll see, I think later today we do some rounding. So you'll see how you can round. But yeah, by default, it won't. Thought that was the case, but you never know if they've changed it. Okay. Oh no, actually, we'll do this one together because you're about to come on to the main exercise in a moment. For time, so let's imagine. So I'll write this. If you're able to easily switch between screens, then you may want to follow along yourself. But don't worry if not, because in a minute you're going to be doing a proper exercise in your groups anyway. So let's imagine we want to write a program that first asks for the username, then asks for their age, and then prints this message: happy birthday, whatever the name is, you are however old today. So let's do this together. Okay, so first of all, we want to grab a name. So I'm going to store that in a variable. I'm going to call it my name. No, actually, let's call it username, would be better. And remember, we want to grab that as an input from the user. So I'm going to use my input command, and I'll just put what is your name as the message. I also need to grab their age, so I'm going to call that user age. Oops. Now again, this is an input, so I'm going to say what is your age. Now, for the purposes of this program, it wouldn't matter if I just kept that as a string, because all I'm doing is putting it into another string and printing it out, so it wouldn't actually make a difference. However, if you're reading in something like age, it's probably good practice at the point at which you read it in to convert it into the format you would expect it to be. So I'm going to convert that to an integer, casting it. So I'm just going to wrap it. I'm going to do it in one statement here. Then I'm going to wrap the integer casting command around this input statement. And then all I need to do is print the message using an F string. So I'm going to put print here. I'm going to put an F to indicate an F string. What did I say? Happy birthday, you are today. Okay, so happy birthday. And then I need the name. So I use my curly brackets on username. You'll be able to tab complete if you're in Spider. So if I hit tab, it'll give me a couple of different things. It's recognized that I've got two things that start user age, and username. So I could select those in that way. So I want username here. You are user age today. There we go. That's my program. If I push F5, run that, you'll see it down here. It asks what my name is. Type in Dan. What is my age? 41. There we go. And it's popped up with a message: happy birthday, Dan, you're 41 today. And if we have a look at the variable explorer up here, we can see the value username here. We've got Dan stored as a string. And up here, user age would have been a string if I hadn't done anything, but I cast that as an integer. So that's now stored as the number 41, which means I can do things like age equals age plus 2. No, helpful, get the name of the variable right. User age equals user age plus 2. And you can see user age has now gone up to 43 because it's a number, so I can manipulate it mathematically. Whereas if I tried that with username equals username plus 2, which would be the same as if I'd kept it as a string. It'll say, there you go, type error. I can't do that. You're wanting me to do something that's done with integers, and it's a string. Okay. So a few last things before we get on to the first exercise. Now, comments are really important when you're writing programs. Comments are basically our way of leaving notes throughout what we've done to make it easier for others, or indeed yourself, when you come back to something after some time, because believe me, you will forget why you've done something or what something is doing. It's to leave notes for you and others to make it easier for you and others to follow. Okay. So they seem like a bit of a trudge to do that. Believe me, it is particularly if you're new to coding, it is very important to get into the habit of doing it now, right in the start of your coding journeys, to leave comments. Now, I will say in advance, there are examples throughout this training where there are no comments in the code that I give you, and that's typically deliberate. and that's because I want you to work out what it's doing. Where I've got code where I don't want you to do that, where I'm trying to explain it, you will see comments. Okay, so comments are very, very important, and there's two main ways of doing comments in Python. We can use the hashtag symbol at the start of a line. The rest of that line will now be a comment, but the second we start a new line, which remember we're going to need to do if we don't want to go over our 80 character width, then it will no longer be a comment unless we put a hashtag again. Okay, so we need to put a hashtag at the start of every line for that format. We can also use, though, the triple double quotation mark notation, which is where we use 3 sets of double quotation marks at the start. Then it turns everything from that point into a comment. So no matter how much you write, you can write on new lines, it'll still be a comment until you close it with the same 3 quotation marks. Okay, and then it'll stop being a comment. So there's 2 different ways. You'll see them used interchangeably as well. I tend to see examples of both. One advantage of this particular, and where you'll see this used quite a lot, sometimes you'll see a comment rather than typically there will be above the line of code explaining what it does. Sometimes you'll see it at the end of a short line of code with a short comment. Sometimes you'll see that, and you can use a hashtag to do that as well. Now, the values that we've got within a Python program, it's usually the case we want to do something with them, manipulate them in some way, and we can do mathematical operations as in any programming language in Python. So here's some of the basics. Obviously, there's lots and lots out there. I'll show you some of the core ones that you'll encounter very quickly. So I want to add 2 numbers together. We use the plus sign. So A plus B, that means whatever value stored in A plus whatever value stored in B. Obviously, you can use the numbers directly as well. You could say 1 plus 3 there, but obviously that's less useful. Usually, you're going to be doing it as variable names. You're adding 2 variable names together, or a variable name and maybe a hard-coded value. Then we've got A minus B, A multiplied by B. Note the wildcard symbol here, the asterisk. That we don't use X for multiplication. That can catch people out. Then new decoding. Don't use X. X is a character. Can be, you might call something X. So we have to use the asterisk here. A divided by B can also catch people out. So we use the / here to indicate A divided by B. This one is really useful. It's known as the modulus symbol. So you'll know it as %, but in Python, we use this to indicate modulus, the modulus operator. What that does is that returns the remainder from A divided by B. So it'll take A divided by B and it'll return whatever the remainder is. That can be quite useful. So if you do 14 modulus 7, 7 goes into 14 twice and there's no remainder. Okay, so the value of that would be 0. So just bear that in mind, because you'll find that quite handy. And then we've got here, if you wanted to do A to the power of B, like you want to do A squared or A cubed or something like that, the way in which you get your number op to say the little 2 or the little 3 is we use the multiplication sign, the asterisk, twice in a row. So A asterisk asterisk B says A to the power of B, so 2 to the power of 3, for example. These 2 down here are also really useful. So sometimes, quite often in coding, you'll want to either increment or decrement a value. So every time you go through a loop, add 1 to that value or take 1 away, for example. And you want to do that quite often. That's quite a common thing you want to do. So much so that they've invented a shorthand for it. So you could say, every time you want to go through your loop, for example, say A equals A plus 1. That would say overwrite the value of A now with whatever A was before and add 1 to it. So that's perfectly valid. But you can also do a little shorthand here where you can use the plus equals in combination. So you say A plus equals 1 means A equals A plus 1. So add 1 to A, or you could put a 2 there or a 3. And you can do the same to decrement. You just use a minus instead. So you'll see this quite often where you see plus equals and minus equals. It's shorthand for A equals A plus 1 or A equals A minus 1. We also talked last week about conditional logic in our principles of programming, and we said how important it was to be able to write conditional logic in our code. The way we do conditional logic in Python is using if, elif, else statements. So let's have a look at an example. Let's imagine we need to print a different message in our code depending on whether or not the age of someone is under 60 or 60 plus. In Python, we could do that using a code that looks like this. So we say here, we use the if statement to say if to Python. So the next thing that it will then check is a condition. So this is known as a conditional statement, the bit you put after if. Whatever you put here has to resolve to a Boolean. So it has to be something that is either true or false, because that's what conditional logic is. It checks if something's true or not. So age is less than 60. And this is the less than operator. I'll show you the rest in a moment. Means, so age is less than 60 is either true or false. Age is either less than 60 or it's not. So we can use that in an if statement. So I'll say if age less than 60, then we put a colon. And then in this block of code here, we put whatever we want to do if that is true. So if age is less than 60. So if that resolves to true, here's where we put it. Now, in Spider, and in a lot of IDEs, when you hit enter after writing this line, it'll automatically indent the code here. That's fundamentally important. It's known as a tab indentation in Python. That indicates this is a block of code that belongs to this thing. So everything that's tab indented here, you can have multiple lines of code, you should only do if that resolves to true. But we might want to do something else if that's not true. So in other words, if they're 60 or over. So we can use the else keyword with the colon, and then whatever we want to do here. So here we check if age is less than 60. If it is, then we'll print please go to room A. Otherwise, if that's not true, if age is 60 or 61 or 82, then this line of code will never run. Instead, Python will jump down here and it'll run this line of code instead. Else statements are optional. You don't have to have them. You may only want to do something if something is true, but if it's not true, then you don't do anything at all. Okay, so you could just have an if statement that has this, and that code is only run if that statement is true, but then if it's not true, you don't do anything else. So you don't have to have an else, but very often you will. There's many different comparison operators within Python, the things that you'll use very often in conditional logic, where you check whether something is true or not. Remember, all of these statements have to resolve to a Boolean value. It has to be either true or false. So I talked earlier about the equals operator, so it doesn't mean that two things are equal. It uses the assignment operator. If you do want to check if two things are equal, which you may want to do in conditional logic, then we use the equal sign twice. Okay, and then that then checks, is A equivalent to B? Does the value of A, is that the same as the value in B? Oops. So we use equals twice. You'll soon get into the habit of doing this. If you're new to coding, it will come to you where equals once means assignment, store value of this in here, and equals twice means are two things equal. Okay, you will get used to that. That also allows us, though, it's quite convenient, because if you want to say something's not equal, then we can use the exclamation mark followed by an equal sign, which means not equal. So exclamation mark means generally no in coding. So no, not equal is exclamation mark equal. Greater than, less than, we can say greater than or equal to. So if we want to accept values that are either greater than a value or equal to it, less than or equal to. We can use the and or keywords as well to check multiple conditions. So here, if we put this in an if statement, it would check, is A equal to B, and also A is less than C. So if that was in an if statement, the block of code under that bit of the if statement would only run if both of those things were true. If A was the same as B, but also A has to be less than C. You might, however, have situations where you've got multiple conditions, but you only need one of them to be true. And in which case we can use the or statement. So this says A is the same as B, or A is less than C. So if we put that in an if statement, the code block that runs after that bit of the if statement would run if either of those things were true. So if A is the same as B, or if A is less than C. One of those things is true, at least one of them is true, then the code will run. We may also have situations where we might want to check multiple conditions and split them out and do different things depending on those conditions. So it may not just be binary, if this, do this, if not, do that. We might want to say, if this, do this, or if this, do this, or do that. So we can use the elif statement to do that. So we can use our if statement in the normal way here. But we might want to say, well, if that's not true, so imagine we're checking age here. So if they're less than 16, print a message saying, please go to the children's room. But we've then got two different rooms for people who are 16 or over. And we need to do another check. So here, I want to check if they're less than 60. Now, we don't need to check again that they're less than, whether they're over 16, because if they've got to this point, then they must be 16 or over. Because if they were less than 16, they'd never get down here, because this code would run instead. And none of the rest of this statement would happen. So we don't need to recheck that. So we can say, we know if we've got here, then they must be 16 or over. So if we say less than 60 at this point, that means essentially they're at least 16, but they're less than 60. That's the only way you could have got to this point. So if that's true, then print this message. Otherwise, print this. So else here basically means they don't fall into either of these categories. They're not less than 16, and they're not between 16 and 60. Okay, we've overrun slightly. Don't worry, we always do on this first session. I want to make sure you've kind of got the basics understood. We've got lots of buffer built in today and lots of time for you to practice this kind of stuff. So what you're going to do now, I would suggest, and we'll extend the break, because I say we've got a bit of time to play with today. So let's extend the break. Let's break for 10 minutes first, because you've had a lot of information to take in there. And then we're going to spend about 35 minutes or so. You're going to work in your groups, and you're going to have a go at an exercise that looks at what you've learned so far. So remember what we've covered. We've covered printing text to the display. We've covered requesting inputs from the user and storing those in variables. We've covered variables, different variable types, and how you cast variables from one type into another. We've looked at mathematical operators, ways in which we can manipulate numerical variable values. And we've looked at conditional logic using if, elif, and else statements. So after your 10-minute break, what you're going to do is you're going to go into your groups, and what I would advise is that you all follow along, but I would get one of you in the group to agree to share their screen. And that's really important to make sure that you're all sort of following along. The first three you want to be talking about as you're doing them, and then when you get to the fourth task, or the final, I think it's the fourth task, then make sure that you're all discussing that as a group, and have a go at that as a group. But throughout all of the tasks, you should be talking to each other and sharing ideas for how you're going to approach that. And make sure that one of you is sharing their screen to help you do that. So you'll see in Jupyter Lab, you'll be able to open this up. Remember, for those of you who have got issues with Jupyter Lab, if they haven't been resolved yet, then you can also open up in Colab. I showed you how to do that, where you can import a Jupyter notebook into Colab and run it on Colab instead. But assuming you've got your Jupyter Lab open, then you need to open this one, Python Prog Workbook 1. So hopefully you've all downloaded the materials from today. Navigate to wherever you've downloaded that and open that up. And you'll see there are 4 tasks for you to do, and explains what you need to do in each task. And then in this code block here, you need to write the code that will do that. And then remember, you can push Control and Enter, and it'll run that block of code so you can see if it works. Okay, so have a go at doing that. Work together. Make sure that you're talking to each other in your groups. Don't just do this on your own. And make sure you're talking to each other and you're helping each other. And then when you get onto this fourth task, this is a bit more challenging. So you'll want to probably tackle this as a group with one of you having a go at it, and you're all feeding in ideas about how you might approach it. Okay, so it's a little bit more challenging than the other three. So have a go. So what are we? 10:35 now. So take a 10-minute break. So resume at 10:45. And then we'll come back here at about 11:20. Okay, but Elliot and I will float around as well to see if any of you need any help. Any questions about any of that? No? Oh no, my Zoom's just crashed. Right, apologies. I'm going to have to crash my Zoom. Hopefully you can still hear me. I'm going to crash my Zoom and resume. Let's see if that works. Hello, I'm back. Sorry, my Zoom every now and then just randomly crashes after I stop sharing a screen. So the good news is that Zoom is very good at just dealing with that and letting me quit and come back in and reclaim my hostness. Okay, so let's stop there.
This meeting is being recorded.
Hi everyone. Okay, so welcome back. I managed to float around about half of the groups. And it seems like you're all getting on okay, mostly. Sorry, and that you were having a go. I saw a few people having a go at the fourth task, coming up with some interesting ways. Most of you on the right lines with that as well. What I'm going to do now, I'll go over the solutions just very quickly. I'll also make the oh sorry, my cat's just collapsed next to me on the floor. I'll make the solutions available. So after each session, as well as posting up the recording, I'll also update and upload the solutions to the GitHub repository for that session. So where we've got solutions, they will be uploaded too. So you'll be able to look at the solutions yourself in your own time as well. So let me just share my screen. Right. Okay. So let's have a look. Where am I? There we are. What I'm doing. So these are the solutions. I'll just go through them very quickly. So the first task, you were asked to input, write a calculator that asks the user to input two numbers, then adds them together and displays the result to the user. So here I've got two variable values, A and B, and for each, I'm sorry, can you everybody make sure they're muted? I'm getting quite a bit of echo. So I've got first I asked the user to input a number here. And then I cast that as an integer, and then I do the same thing for B. Again, I could separate that out onto separate lines, but I'm choosing to do it just in one line here because it's easier. And then I can just add the two together because I've stored them both as integers, and then I can print in an F string. The result is whatever's stored in results. If I put in 10 and 7, the result is 17. Now, because I've stored the result value up here, that I can use it anywhere else within the Jupyter notebook, because it's now in memory in this session that result holds a value of at the moment 17. So this bit where you had to check whether the output was 1 million or more, and if it is, then display a message saying, wow, that's a big calculation. And oh, sorry, so I can actually see. If you haven't, you'll need to make sure already, you need to make sure you've stored it as a variable up here. So I can run that now. That's not a large number because the result was 17. If I rerun the above one, and let's just do something really big. And now if I run this again, I can see it says, wow, that's a big calculation. So there's a really simple if statement here where I check if result is greater than or equal to 1 million. Make sure you don't use I deliberately did this just to be a bit mean. You can't use commas in the numbers here. It will think it's separate things. It'll think it's separate numbers. So you have to do it commaless. So if result is greater than or equal to 1 million, it'll print this message. If it's not, then it'll print this message. Nice simple if statement. In 3, this was basically a little bit of a fabricated example just to get you to try out a few different things. So again, we get 3 pieces of input from the user, a length, a width, and a height in centimeters. I'm going to cast them as integers. So then I've now got length, width, and height stored. And then if they're all the same, then I can say this is a cube, and I'll print. I'll calculate the volume by using the double asterisk. Otherwise, I'll print that it's a cuboid, it's not a cube, and I'll calculate the volume as length times width times height. Now, you could do the same thing. You could use length times width times height for the cube as well. Obviously, that will give you the same thing. But I just wanted to get you to use 2 different approaches just to practice them. So I'm using the AND statement in the if statement here, so that I can say if length is strictly equal to width and length is strictly equal to height. You could have checked width against height as well, but if those 2 are the same, then you need to check one of those against height, and then if that's also true, then they're all the same, and then you know it's a cube, and I can put that to the power of 3. Otherwise, we'll do this. Then for task 4, I think most of you that I saw got there. It was a little bit, just to get you think a little bit outside of the box. There are obviously different ways you could do this, but I was trying to get you to do it using only what I've shown you so far. And you can do it using the modulus operator. So what we can basically do is get the user to input a number. Strictly speaking, I should probably have a check up here to make sure they don't input a number above 365, but doesn't matter too much for this. So it will allow them to input a higher number or indeed a lower number, and it'll crash if they do. But we can use the modulus operator, and the way we can do this is, remember, modulus gives us the remainder of a number. So if we think about what the 7th day would be, because we start with day 1 is a Monday, we know the 7th day is a Sunday, which means if we take 7, how many times does 7 go into 7? Once, with a remainder of 0. That will also hold true for the following Sunday, which will be day 14, where 7 will go in twice, but the remainder will still be 0. Similarly, for a Monday, the following day, the 7 will go into that day number however many times, but there'll always be a remainder of 1. And if you think about it, the first 7 days, so day 1, if they input a 1, 7 goes into 1 0 times, but you've still got a 1 left. Similarly, day 2, 7 goes into it 0 times, you've got a remainder of 2, etc., etc. And you only need to do that for these first 7, and then from day 8 onwards, then 7 will go into 8 once, but with a remainder of 1, and you're back around again. Okay, so there's more elegant ways you could do it as you go on through the Python, but this is an easy way that you can do stuff like this. And I've just put a little else statement down here. You should never get to that point unless something's wrong in your code. It should always be one of these things. Okay, any questions about any of that? No? As I said, I'll make these solutions available for you as well, so you can have a look through it in your own time. But it looks really good what you've done so far. You should be proud. You've written your first Python code in a lot of cases, and you've done really well. So fantastic. So let's move on to the next topic. Okay, so now let's talk about loops. So we talked last week in the principles of programming about loops and where we might want to use loops. So remember, we said that often in our code we may need to do the same thing a certain number of times, or we may need to do the same thing continuously while something is true. And we've got 2 different kinds of loops that we can use for that, a for loop and a while loop. So for loop will say, do this thing or this set of things a certain number of times, and a while loop will say keep doing this whilst this condition is true. So let's look at for loops in Python first. So for a for loop, we use the for keyword, and we use a little variable value here that essentially acts as an index for the loop. Okay, so you can call this anything like, I call it X, you can call it, you know, cupcake if you like, it doesn't matter. It's essentially just the name of a temporary variable that will store the index where it is at that loop, in that loop at any one time. So what we're saying here for X in range 10 is saying go through and do all of this stuff in the body of the for loop such that for a value of X, which will start at 0, remember we start counting at 0 in most things in programming languages, although you will see some stuff in Python which it doesn't start at 0, just to throw you off. But don't worry about that for a moment. Most things will start at 0. So what will happen is it'll start with a value of X as 0. Then in this for loop, it's just going to print whatever the index is. Okay. So here it's going to print the value of X, and you can see the first value will be 0. What it'll then do, it's got to the end of that for loop, it's only a single line of code, but it could be multiple lines of code. X will now increment by 1. So it'll go up to 1, and now print the value of X, which is now 1, etc. And it'll go through it 10 times, but starting from 0. So when we put in range, this means go for an iterable object, up to but not including the value I give here. So if I put 10, it will never get up to 10. As soon as it gets to 10, it'll stop and it won't run the for loop. But remember, because it starts at 0, that will still give us 10 iterations. It'll give us 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'll go through it 10 times, starting at 0. That can throw you off a little bit sometimes. So you need to be aware of that it goes up to but not including, but it also starts at 0. Now we can set up, if we like, a custom range. We don't have to start at 0. We could start at another value. Now you won't use this quite so often, but there may be case, because normally you're less interested in the index value and you just say I want to do this 10 times or whatever. But it might be that the index value is quite important, and it might be then that you need a certain range. You want to start at a certain point and end at a certain point. So you can actually set up a custom range. So here, X, the index, will start at 10, and it will go up to, but won't include 20. So we'll still get 10 iterations, starting at 10, but it'll never get to 20. So it'll do 10 through to 19. Okay, so it's exactly the same as before, but rather than start at 0, we'll start at 20. We'll start at 10, sorry. Now, if you weren't actually doing anything with the index value, that's completely pointless. It's just doing the for loop 10 times. But in this case, we're printing the value of X. We're doing something with that index. So therefore, it might make a difference. We want to start at 10 for some reason. You can also customize the increment. You don't have to go up by 1 each time. So you could, for example, go up by 2. So in this statement here, we're saying for X in range, and the specifying the ranges start at 0, start at 2, go up to, but don't include 30, and go in increments of 2. So I'm just going to shut the door because my cat's going right now. Okay, so yeah, we start at 2, we go up to, but don't include 30. But this time we're going to go up in increments of 2. So rather than the default of 1, which if you don't put anything in, which most of the time you won't, it'll go up in increments of 1. Here we're counting in increments of 2. So you can see if we print the value of X, we can see the index value starts at 2, but then the next time around the for loop, the index is 4. Then it becomes 6, then 8, then 10. And it'll go all the way up to 28, but then it'll increment by 2 and it's hit 30. And so therefore it'll stop the for loop. We can do the same as well with a for loop that decrements the index. So we could start at 10 and go all the way down to, but not including 0, with an increment of -1. In other words, a decrement. So go down, reduce the index value by 1 each time. So if we do that, we start at 10, we printed the index value each time. We can see we start at 10 and go to 9, 8, 7, 6, 5, 4, 3, 2, 1, and then it would go down to 0 and the for loop never runs. as well as using an index, which is one of the most common ways you'll do it, to say, basically do this series of stuff X number of times. We can also, though, iterate through an iterable object, such as a list. An iterable object in Python is just something that you can iterate through. Okay, so a list is one of the most common uses of one of the most common examples of an iterable object, and the thing you probably use the most as an iterable object in Python, possibly with dictionaries as well. So rather than iterate through a series of index numbers, we can iterate through the elements of a list. So I've set up a list here called my list. It's got 5 values in it, 1, 10, so these are integers. I've got the string Dan, I've got a Boolean value of true, and I've got a string HSMA. What I can do, rather than say go through it 5 times and print that, I can say go through each element, and then I can refer to the element itself. So again, I've put a variable name here. I've called it element. I could call this anything I like. Again, I could call it cupcake if I like. But for whatever variable value in my list, what will happen is it starts at the first element here. The value of element now becomes whatever that first value is. So rather than an index of 0, it starts with this variable value as being whatever the value is here. So it'll be 1 the first time around. And in this loop, I'm just going to print whatever it is. We print that value, the same as I did before, but this time it'll print a value of 1. The next time round, it'll now move on to the second element of the list. And now the value of element, the thing that's keeping track of where I am, is not an index, remember, it's now the value itself. So it's now 10. So if I print that, 10 will be printed. Move to the next one, Dan will be printed, etc. And this, you'll find this quite useful, particularly when you come on to do object-oriented programming, where you can have a list of objects, and then you go through each element of the list and say, okay, for this patient, give me their patient ID. Okay, and you can do that through a loop by having a list of patient objects and then grabbing their ID out, for example. So you'll see how this becomes quite useful. So that's for loops. Quite simple how we do it. We just use the for, the name of a temporary variable that's set up just for iterating through the loop, in, and then either a range or an iterable object. Now, I should say, just to explain, essentially the two things are the same. A range is in itself an iterable object. That's why it works. Okay, but you don't need to worry about that. Okay, so that's for loops. What about while loops? So let's imagine we want to set up a loop that continues doing something whilst something is true. So let's imagine we've got a simple example here. We've set a value, a variable value, a variable called correct. It's a Boolean variable, and we're going to set that to a value of false. And then I've set up a while loop here and say, keep doing all of this whilst correct remains as false. Okay. So I say while correct is strictly equal. Remember the double equal sign to false. Use my colon. Now I'm in the body. So all of this will be carried out whilst this condition remains true. And the condition it's checking is correct equal to false. So what I'm doing here, I'm going to ask the user to input whether they think Dan is the best. If the answer is yes, then I'll print that's the correct answer. And at that point, I can set correct is true. That means that we won't go around this while loop again. We'll stop because now correct is no longer false, so that we can break out of this while loop. Otherwise, if they put in anything else, then it tells them to think hard and try again. So we'd keep going around this loop until we set correct to true, and then this while condition is no longer true. Okay, because it's true. Because the correct is now set to true, which means the while condition is false. Correct is no longer equal to false. So sometimes as well, we may need to break out of a loop mid-flow. So we might have, for example, a for loop, and we want to break out of it when a certain condition has been met. And we can use something called the break command to allow us to do this. Basically what break does is it says, right, don't carry on, just exit the loop as though you'd gone through all of the iterations and come out of it. So here's an example. We've got a variable that's set up to called total, assign a default value of 0. And then I've got a simple for loop here, which says for x in range 10. So keep iterating through 10 times, starting with an x of 0 all the way up to x is 9. But what I'm doing here is I'm saying keep a running total. So I've got a new variable value that I've called total. And total is whatever total is at the start right now, which at the start will be 0. So the first time through total will be 0. And add on this x, this index value. And then print it, and then check if the total is greater than 5. And if it is, break. In other words, come out of that for loop, don't do any more. So let's look at what that would output. So the first time round, total is 0, x is 0, because the first index around the loop will be 0. So we'll have here total equals 0 plus 0, which is 0. So it'll print 0. Is the total greater than 5? No, in which case, back round again. This time, remember, x is 1. So now we've got total is still 0 plus 1. So now we've got a 1 total printed, but it's still not greater than 5. So round again. Now x is 2, because it's the next index value. Remember, our total is now 1. So now we've got total equals total, which is now 1 plus x, which is now 2. So we've got a total of 3, but it's still not greater than 5. But when we go round again, we've now got an x value of 3 and a total value of 3. So now when we add the current total, which is 3, to the index, which is 3, we now get a value of 6, which we print. But now total is greater than 5. So we'll now end up in this bit of the code, and we'll run the break command, and the loop will stop. So it won't go all the way up to do its 10 iterations. It's only done 4. And then a condition has caused it to exit that loop, and then it'll just carry on after the for loop as though it had completed. And that can be quite useful. Now, sometimes when you're dealing with loops, you can accidentally, and it usually is accidentally, write what's known as an infinite loop, one that will never ever end. Okay. Now, those fellow oldies like me that remember playing around with computers back in the old days and coding on their Ataris and their Commodore 64s and their ZX Spectrums and what have you, will probably have done this quite soon after getting their computer. That famous program, 10 print hello world, 20 go to 10. So in BASIC, for those who don't know, you basically had line numbers, and it would go through, and you could go back to certain line numbers. What this is an example of an infinite loop. It says print hello world to the screen, and then the next instruction is go back to 10, at which point it'll print hello world to the screen. Then it'll go back to 10, and so it's an infinite loop. It's just stuck in an infinite loop. It'll forevermore do this, and it'll just keep printing hello world. But there are more modern examples of infinite loops. So here's an example of an infinite loop. We've set a value, a variable value of 3 to a variable called x, and we say in this while loop, while x is greater than or equal to 3, print the value of x, and then add 1 to x, which means the next time around it'll be 4. So it'll always be greater than or equal to 3. It's never going to go below 3, because the stuff you're doing in here ensures that will never happen. So you'll never break out of that loop. It'll just keep printing higher and higher numbers. Here's another example where I've said, so remember this in a while statement, you've got a conditional statement that you're making here. So over here, the statement is x is greater than or equal to 3. Again, is it true or false? It's a piece of conditional logic. But here, we're just saying true. We just use the Boolean value true. And what this is when you typically want to write a deliberate infinite loop. Okay, and there are cases where you actually want that to happen. And the easiest way to do that in Python is to use while true, because that says essentially that's shorthand for whilst true is true. Now, true is always true because true is true. And therefore, that basically says whilst true is true, which is always true, therefore do this forevermore. So it's an easy shorthand for do an infinite loop, because true can never not be true. So here I'm just going to print Dan as the best, and again we'll have another example of an infinite loop. Now you'll see examples in the course of where you may want to write a deliberate infinite loop, and usually you'd use the while true statement. For example, maybe you've got a little menu system, you've got the user selecting certain inputs, and you want to keep doing that until something else happens, at which point you may then use a break statement to get out of that infinite loop. But if you've written an infinite loop accidentally and you didn't mean to do that, and you are now stuck in this infinite loop thinking, what on earth do I do? Don't worry, you can get out of an infinite loop. All you need to do is, if you're in Spider, for example, go into the IPython console. You need to make sure you clicked on the IPython console, the interactive Python console, if you're in Spider, and hit Control and C together, and that will cause what's called a keyboard interrupt, which it basically says, okay, sorry, the user said stop, I'll stop, and it stops the code. If that doesn't happen, sometimes, and you'll see in the next exercise, that if that doesn't happen, and it sometimes doesn't, I'll show you how you can basically restart the kernel and it'll just reboot and force it. Sometimes it's a bit fiddly, but usually a Control C will stop it. Okay, let's have a go at the next exercise. So what you're going to do now, we've learned about for loops, while loops, and breaking from loops. So you're going to, again, go back into your groups and have a go at Python Pro workbook 2. So let me bring that one up, not the solution though, at this stage. So here again, you've got 4 tasks to do. So we'll give you about 25 minutes or so. I'll see how well you're getting on. And then I'll make a judgment call, but I'll be floating around the groups. So here again, you've got 4 tasks. Do as you did before. Make sure that somebody in your group is sharing the screen, and make sure you're working through all of this together. And again, task 4 is a little bit more challenging than the other ones. Not in terms of the amount of code you've got to write, but just in terms of how you think about approaching that. So have a go at these tasks, and Elliot and I will float around if you need any help. Okay, I'll open up the rooms.
This meeting is being recorded.
Hi everyone. Okay, so I'll just put you back. I think most of you were most of the way there, if not quite all the way there, but it looked like you were all on the right lines. I'm just going to very quickly go through the solutions, but if you didn't quite finish, it's worth after the session just going back and having a look at the bits you didn't quite get to. But I just want to quickly rattle through some stuff just before we break for lunch, because you're going to go into an exercise straight after lunch. So let me share my screen. Okay, so where are we? Okay, so I'll just quickly go through these solutions. So the first task, you have to basically do a times table type thing based on whatever number the user input. So we grab our chosen input here from the user, cast it as an integer, as you're used to doing by now, and then have a for loop that starts at 1. Remember, we would by default start with 0. So we need to put in a starting number of 1, and we're going to go up to and not including 13. So that will give us 1 to 12. Okay. So then we just have, for each time for that for loop, we'll print whatever this number is, the index number, which will be 1, 2, 3, all the way through to 12, multiplied by whatever the chosen number is, and then the answer. So if I run that and I type in 3, it'll give me my 3 times table. Okay, so fairly straightforward, but just getting you to play with loops a little bit. Then the second task, we have a list called Pencordians, and I've got 4 string values: Dan, Tom, Sean, and Kerry. And then this time I'm going to loop through each, rather than an index. My temporary variable is going to be contain the value of that element in the list. So again, I can call this whatever I like. So I've called it something meaningful here. So I've said for team member, because that's essentially what each of those things is. So for each team member in Pencordians, print the message, hello, that team member. So if I run that, we can see it'll start with Dan being the first one. It'll say hello Dan, then move on to Tom. So Tom is now stored in team member. It'll say hello Tom. Then Sean is now stored in team member. Hello Sean, etc. Then for the third task, you had to write a piece of code that asked the user to input a number and to keep doing that until the number entered is more than 100. But if the user enters 0, then the program exits with some sort of appropriate message. So we grab the user input here, then we set up a while loop. And basically we're going to keep doing this whilst the user input is 100 or less. So while it's less than or equal to 100. But we'd also need to check if it's a 0, because if it is a 0, then that will exit the program. So we'll print a little message saying exiting program, and we'll break. So that will be as though the while loop was no longer true. Otherwise, if they didn't input a 0, then ask them again to input a number, and it'll keep doing that until this is no longer true. So the second, let's try that out. I input 5, it'll ask me again. 87, it'll ask me again. 102, then it stops, because it's now, this while loop is, this condition up here is no longer true. So we exit the loop. And similarly, if I type in a value of 0, it'll exit. So there's 2 different ways you can exit that while loop. And then for the fourth, slightly more challenging task, again, we rely on our good friend Modulus to get us through. So what we can do here is different ways you can approach this, but a nice elegant way you can do it here. You basically are printing every second day, you're printing the day number, but then also on every 4th day, as well as the day number, you need to print out a message to go shopping. So the way I've done that here is set up a custom range that starts at 2 and goes up in increments of 2, up to, but not including, well, I put 365 there. It'll also work if you do 366. Basically, you can put in, even though you're going up in increments of 2, so once it gets to 364, it would then naturally jump to 366. But because that exceeds the limit you've put in there, it won't then run. So you can think of it as a kind of max. So basically go up in increments of 2, from 2 up to and including 364. Every time you do that, print the day number, because you want to do that for every second day. And we're going up in increments of 2. But for every 4th day, which we can find by taking day modulus 4, if that's 0, then it's divisible by 4. So it must be one of the 4th days. And I can print this message saying go shopping. And if I run that, prints day 2, day 4, go shopping, day 6, day 8, go shopping, etc. Okay. So relatively simple piece of code, just needs a little bit of sort of thinking around that. But hopefully you're starting to see how Modulus can be quite a little useful little operator. So if you didn't manage to get through all that, as I will post up the solutions after the session, so you'll be able to have a look back through these in your own time. Right, I'm going to see if I can squeeze in the last bit before lunch. I'll make sure we still get an hour for lunch. So let's just go to the last bit before we break. And let's talk about lists. So lists are incredibly useful, and you'll be using them a lot in your coding. And they're incredibly useful for storing multiple values within a single variable. So here's how we set up lists in Python. So if we wanted to create a brand new list that was empty, then we just use the square bracket notation. We give it the name, and then we say equals, and then open and close some square brackets. That creates a new list called my empty list, but there's nothing in it at the start. Okay, so sometimes that's what you want to do. You just set up a new empty list, and then you're going to start adding stuff to it. Pops through a loop, for example. In some cases, you might want to create a list with some values already in there, and in which case you can do the same thing. Except rather than nothing in the square brackets, you can just put whatever values you want as your starting values. So in this case, my list will start with 3, 4, 7, and hello. Now, if we want to add an item to a list, we use the append function. And we use this dot notation, which you'll start to see increasingly now as we go through the coding. Basically, dot means use a method or grab an attribute from an object. So in this case, what we're saying, the list is actually an object. We haven't explicitly said, we haven't got onto the object-oriented programming yet. But essentially, if you remember back for last week when we talked about the principles of programming, we said that objects have attributes, variables essentially, and methods, functions. And so the dot notation says within the list called myList, which is actually stored in Python as an object, I want you to use the append function. So because we've created a list, we happen to call it myList, but it's essentially we've created an instance of a list, and that lists in Python contain lots of functions, and one of the functions of a list in Python is a function called append, and that function basically allows you to add an item to a list. So we can say the name of our list dot append means call the append function of the list object, and the thing we pass into it is whatever we want to add. So here I'm adding a value of 2. You can actually add an entire list, you can add multiple values, whatever you like. And then I can, if I print my list here after appending, you can see it's gone from being 347 hello to also adding 2, so adds it on to the end. We can also use the extend function, which will add multiple items to a list. So append if you want a single value, extend, as I mentioned, if you want to add more than one value, we can use the extend function. And what we can do is we can give it another list which contains all of the values that we want to add. And what extend will do is it'll take all of those additional values in that new list and bung them into the first list. Okay, so if I've got a list set up here called myList, which has the values 1, 2, 3, 4, and 5, I can call the extend function of my list, and I'm going to pass in another list here. Now I haven't created a variable name or anything for that list. I've just created on the fly. Essentially, the square brackets say this is a list. So I've got a list here, and it contains the values 6, 7, 8, 9, and 10, and I'm going to pass that as the input to extend. And if I then print what my list looks like, it's now the values 1 to 10, the original 1 to 5 values, and then the extend function has added each of those values in turn to the end of that list. So we've got a single list that contains all of those values now. So append if I want to add one value onto the end, or extend if I want to add numerous values, multiple values. Now, when we want to refer, remember lists are ordered. The order matters in a list. So if we want to refer to the specific item within a list, we use the square bracket notation, and we pass in an index value. Okay, so if we remember, in Python, as in most programming languages, we start counting, for this anyway, and for most things, from 0. So the first element will have an index value of 0. Okay, so if we want to get the first element, we would say my list, open our square brackets and put an index of 0 would give us the first element. The second element would have an index of 1. The third element would have an index of 2. Fourth element, index of 3, and the fifth element, index of 4. Okay, it sounds obvious. That will catch you out if you're new to coding. So remember, you need to start counting from 0. The first element will be 0. So if I print my list and then open square brackets 2, that refers to the third element here. That's the value of 7. We can also use negative indexing if we want to refer to an item based on its position from the end of the list. And here's where it gets a little bit more confusing. If you probably won't do this quite so often, but if you do this, then essentially we can use a negative value. And in this case, -1 would give us the last item in the list, which technically means if you're then reading from right to left, then that is the first element is a 1, essentially a -1. The second element back is a -2. So it kind of spins, because obviously 0 is reserved for talking about the first element of the list. So -1 is the last one, -2 would be the penultimate item, etc., etc. Okay, you won't tend to use that quite so often. If you do, it's usually to grab the last element, but you don't tend to use this quite so often. As well as referring to a specific value, grabbing out a specific value, we can also grab out multiple values, and we can specify a range of indices. to specify the chunk of list that we want back. So let's imagine we've got a list again here of 347 hello 2. If we want to print everything from the second element up to but not including the fourth element, we can use this notation. So we can say within our square brackets 1:3. So remember, it includes the first number here, but does not include the second number. So that says print everything from index 1, which will be the second element, up to but not including index 3, which would be the fourth element. Okay, so that would then print us so index 1 would be 4. It would also then print 7, but it would not print index 3, the fourth element, because it doesn't include that. So this is a way of saying print the second and third elements. If we wanted to print everything up to but not including the third element, then what we can do, we don't have to put values on both sides of the colon. We can skip one. So if we do that here, we say, give me everything up to this point from the start. Oops, from the start up to but not including. So here, I want everything from the start of the list up to but not including index 2, which remember would be the third element. So in other words, give me the first and second elements, the ones at index 0 and 1, which would be 3 and 4 here. And we can do that the other way around as well. We could say print everything from the fourth element onwards. Remember, the fourth element would have an index value of 3. So that's hello and 2. So you can specify the start and the end, but remember the end, it will never include the end. So you need to go one above. Or you can say, give me everything up to this point, or everything from this point up to the end. We can also remove items as well as adding them. And there's different ways we could remove items from a list. Two of the most common ways are remove and pop. So the remove function, we call on a list if we want to remove a specific value by giving that value. So here in our list 347 hello 2, if I say my list.remove hello, then it'll look for the value hello and it'll remove it from the list. If I then put the list back, pop essentially removes an item from a list based on its index. So rather than saying look for this value, it says remove whatever value is at this index. So here, if I say my list.pop3, it'll look for whatever value is at index 3, 0, 0, 1, 2, 3. So that's also hello. Both of these will remove the word hello from the list. But we can do it either by saying I want to remove this value, or I want to remove whatever value is at that location. Also, crucially, and this, hopefully you saw my message, I realized that this wasn't actually included in the notes, even though it's in the title. But if you go to GitHub, if you haven't downloaded it since Sunday night, the updated version of the slides will include this bit, how you find the length of a list, and you'll need to do that quite often. Sometimes you'll want to set up a for loop based on the length of a list. So you can use the len function. And basically, if you say the len and then open brackets and then pass in the name of your list or any iterable object, then it will return how many items there are. That's the length of the list. So in this case, we've got a list that has the numbers 3, 9, 1, and 2. If I print the length of that list, I'll get a value of 4. It's got 4 elements. So finding the length of a list is actually really handy for a lot of things. We can also check whether an item is in a list using the in command in Python. So here I've got my old list back 347 hello and 2. I can check if something's in there, and I can just do this. It's quite nice. It's quite a sort of plain English syntax that makes it quite readable. I can say if 2 in my list. There's no is, so be careful of that. So that says if this value is in this list, and then if it is, then do whatever code's there. So I'm just going to print a message, it's already there. So it's really handy to check whether an item is already in a list, or indeed in any iterable object. So that in method will work for other iterable objects like sets or tuples or dictionaries. Now, you might sometimes want to take a copy of a list because you need to have two copies and work with them separately. So you might be tempted to think that one way to do that would be to say, let's say I've set up my list here, and then I'll create another copy of it by saying copy of my list equals my list. Okay, sounds reasonable based on what we've seen so far. That won't work though, as expected. What do you think will happen?
Rename it.
No. Well, sort of.
It'll refer to the underlying object.
Yeah, so basically what happens in Python, it will create another reference to the same list. So you'll still be able to refer to my list. That will still work. But it'll also, you can say copy of my list, and it'll refer to the same list. You'll just essentially have two ways in which you can refer to the same thing. Okay, that means that if you've done this, as you likely have intended to do it, because you want to then manipulate them separately, thinking you're changing a copy of the list, you might then be slightly horrified to notice that it's anything you do to one list, you're doing to the same list, because you've just got the same, there's only one list still, you've just got two ways, two names for the same list. That's usually not what you want. Maybe it is, but there aren't going to be that many situations probably where you've got two different names for the same list. What's more likely is that you were intending actually to have two separate lists, and you were taking a copy of one of them. So to do that, you can do that, and you can use the copy function within a list to do that. So if I wanted to create a copy of that list, I can say mylist.copy, and that will now create a brand new list that will be a copy of this list. Now I've got two lists, and whatever I do to copy of my list won't affect my list. Okay, so I can work with them separately, which is probably what you want to do if you were doing this. Now, there's a really neat feature in Python, which is a really nice example of why I like Pythonic code. Something called list comprehension. You can also do this for dictionaries as well, but I'll explain it in lists, because this is where you'll see it most often used, and it's the easiest to explain. Basically, what list comprehension allows us to do is to create lists that are based off other lists using just a single line of code. Okay, you might have trouble getting your head around that. So let's look at an example. Let's imagine we've got a list of numbers, and we need to create a second list, which is all of the numbers in the first list, but doubled. Okay. So one way we could do it, using what you've learned already, we could set up a list A, which is our numbers, and then set up a blank list B, and then have a for loop that says for each number in list A, append to list B whatever that number is in list A times 2. Okay, that'll work. You can create a second list. But there's a neater way to do it, and that's to use a list comprehension. So what we could do here, again, I'll set up my list A here in the same way as before. But for list B, rather than have that for loop, I'm going to have a single line of code that does all this. So what this does in a list comprehension, we use the square bracket notation to say this is going to be a list. But rather than give the values themselves, I'm going to give a piece of logic. Now, it's usually easiest. Sometimes it can be difficult to get your head around a list comprehension initially. They'll become second nature after a while. But a useful tip as you're starting out is to start in the middle here. Start with the for. So what this is saying is for every X in list A, and X could be anything, but essentially for every element in list A, give me that element doubled. Okay, so it's X times 2 for every X in list A is what that says. So go through each element in list A and give me double it. And that single line will then create a list that does exactly what we did over here, but in a single line of code. And it also means that we can add in conditional logic. into a list comprehension. So it might be, for example, let's imagine we've got a list and we want to form another list where which only includes elements from the first list that meet a certain criterion. So here, imagine we've got the numbers 1 to 10, and then we want to create a second list where we only include even numbers. And remember, we can check if a number is even just by using the modulus operator. Modulus 2 equals 0 will mean the number's even. So we could do it the longhand way here of going through each element in list A and then checking if that number modulus 2 is 0, and if it is, then we'll add it to the second list. That's fine. But we can do all of that in a list comprehension. So all of that for loop there, we can replace in that single line of code. Again, let's start with the for. That'll help you read it. What this is saying is, for each number in list A, if the number modulus 2 is strictly equal to 0, then give it to me. Add it to this list. Okay, so give me each number for each number in list A if number modulus 2 is 0, if it's even. So that's a much more elegant way, and particularly as you go on to do more complex logic, list comprehension is a really neat way to very elegantly create brand new lists based on logic. So just before we close for lunch, I'm just going to talk very briefly about dictionaries. Dictionaries are the other big thing that you'll be, the other big iterable object that you'll be looking at quite a lot. And it allows us, remember, to store key value pairs where we look up have a lookup value and then have an associated value with that. So here we've got my patient dictionary. I've set up as a dictionary, and I've got 4 key value pairs. I've got a key of patient ID, and associated with that is an integer value here. I've got a key of name associated with this string Bob Smith, a key of year of birth associated with the integer 1961, and a key of readmission associated with the value true. So if I print that, I'd get all of those values, and they would come up as key value pairs. That means I can look up certain values. So and I can do that just using square bracket notation, much as with lists. Only this time, rather than passing an index, well, you're still passing in an index, but here the index is a lookup value. Okay, so here I can say, okay, give me the name. So what it'll do is it'll look up, oh yes, you've got a key value pair where the key, the lookup key, is name. So I'll give you the value associated with the name, in this case, Bob Smith. We can also add elements to a dictionary really easily. We simply set up a new key value pair. Let's go with the changing first. So if I wanted to change a value, so let's say I've got year of birth, currently 1961, and I want to change the year of birth that's associated with this in this key value pair, then I can just refer to the year of birth using the square bracket notation, and I just overwrite it using equals, and I set whatever I want my new value to be, and now year of birth will be 1960. If I want to add a new key value pair, really easy with a dictionary, you just use the square bracket notation to refer to a key that doesn't exist. So here, month of birth is a new one. Rather than, Python won't say, oh, you haven't got something called month of birth. It'll say, okay, you want a new key called month of birth, and here's the value that's going to be associated with that. That can be both a blessing and a curse, because maybe you've done a little typo and you meant to change year of birth and you typed in year of birth with 2 H's or something. Python won't say, I don't know what year of birth with 2 H's is. It'll say, oh, great, you want a new key value pair that has year of birth with 2 H's. So be aware of that. Just keep an eye on stuff like that, because that's where Python can be a little bit, because it's quite loose with this stuff. You can fall into traps, and you'll merrily be going through your code with no errors coming up, thinking, oh great, and then you'll get to the year, something that deals with the year of birth, and think, why is that not working? And that'll be why. We can also really easily delete a key value pair that we no longer need. To do that, we use the del keyword. And we just put del, then the name of our dictionary, and then in square brackets the name of the lookup value, the key, and that will delete that key value pair. Okay, so we can refer to them in the square bracket notation just by giving the name of the key. We can change the value by giving the name of the key and then the value we want to overwrite. We can add a new pair by giving the name of a key that doesn't exist and the value, and we can delete them as well. Right, we're going to stop there. So we've overrun slightly, but it's important that you still get a good lunch break. So what I suggest we do is we break now till 1:40. Okay, so we'll come back at 1:40. But what you're going to do, we're not going to have a lecture at that point. You're going to go straight into the next exercise, and you're going to spend the first 40 minutes after lunch in your groups going through the next exercise, which is Python Programming Workbook 3. So break to 1:40, then go into your groups. I'll open up the breakout rooms now so that you can go in whenever you're ready. So at 1:40, come back here, go into your breakout rooms, and then we will resume the lecture back at 2:20 Okay, you can stay on the Zoom call. I'll keep the Zoom call open, so you can stay on the call. That's not a problem. If you do that, just make sure that you're muted and you've turned your camera off before you leave. Okay, brilliant. Let's stop there. Go and have a lunch. Come back at 1:40. Go straight into your breakout rooms and have a go. And Elliot and I will float around and help. Brilliant. See you in a bit.
Being recorded.
Hi everyone. Okay, so I think most of you got through all of that, or most of it. So I'll go through the solution, then I'll just mention something that cropped up, which is probably worth mentioning at this stage, early in your programming careers as well. So let me just share my screen. Okay, right. So you had 3 tasks on this one. The first, which you have to write a program that asks the user to name their 5 favorite things in the world in descending order and stores them in a list. Then it'll remove the last 2 and print out the top 3 to the user. Now, there's multiple ways you could do this. What I did see quite a few people doing though was, and it's quite natural, sort of early in your programming careers to do this. It was quite a common mistake. Not using a loop. We're actually, and I saw a lot of people sort of writing 5 input statements. That will get very tiring very quickly, especially if you have to suddenly do things thousands or even millions of times. So remember, you can use loops. If you need to do the same thing multiple times, use a loop, and always think, can I do this in a loop and do this in 2 lines of code as opposed to 100. So first thing I'm doing, I'm just going to print a little message. Please enter your top 5 favorite things in descending order. Then I'm going to have a list that I created. I've just called it my list of favorite things. And then I'm going to have a loop that loops around 5 times. And each time it says, so the user grabs an input from them, asks them to enter their favorite thing, or please enter a favorite thing. You could, of course, be a little clever about it if you want and link it to the index. You could have a decrementing index if you wanted. But I'm just asking exactly the same thing each time. And then whatever thing they put, I then append that to my list of favorite things. So after I've been around this loop 5 times, I'll now have a list of 5 favorite things. And then I just want to remove the last 2. There's a couple of ways you could do this, but I've just chosen to call the pop command twice. So I'll just call 2 pops there. Remember, pop will remove the last element from the list. And then it'll then print out the top 3. And it just loops through the, I've said the thing in list of favorite things, print the thing. Print whatever element it is. Now, of course, there's lots of different ways you could do that. You could have sliced the list, like I showed you, having the notation. There are multiple ways, given what I've shown you, that you could have approached that. But this is one way in which you could have done it. So if I run that, favorite thing, HSMA, more HSMA, HSMA 5, Python, and not R. So my top 3 favorite things are HSMA, more HSMA, and HSMA 5. Okay, so then task 2, write a program that asks the user to input 10 numbers which are stored in a list. Then using a single line of code, that's your clue. Create and print a new list that contains only numbers that are both odd and less than 100. So I create my new list here. Then I'm going to use a loop again. Use a loop here. You're doing the same thing multiple times, so we can use a loop here. So here I'm going to be doing it 10 times. where I want to ask the user to input a number, and remember to cast, it's going to come in as a string. So if these are numbers and we're going to deal with them as numbers, we're going to need to cast them as integers. So I cast that as an int, and then I append that casted integer into my list of numbers. So by the time I've gone through this loop 10 times, I'll now have a list of numbers that is 10 long. And then down here, I'm then going to do a list comprehension. And just to be extra cocky, I've put all of this in the print statement. You could have separated this out, but I've just put it all on a single line. But the important thing here is the list comprehension. Okay, so remember, we could have done this longhand, but list comprehension allows us to do this in a single line of code. So what this is saying is make a list and make that list of elements I call num, which represents for each num in list of numbers, so my list of 10 numbers, if the number is less than 100 and it's odd. And I check if it's odd by taking the number modulus 2. And if I get a remainder of 1, it must be an odd number, because if I divide it by 2, there's 1 left, 1 as my remainder. So that says for each number in my list of numbers, if the number is less than 100 and the number is odd, then give me that number in this list. So that list will then only consist of numbers that are both less than 100 and odd as well. Okay, so list comprehension takes a little bit of getting your head around, but once you do, you'll wonder how you lived without it, because it is hugely useful, really useful once you start getting into it. I'm sorry, I saw a hand raised.
Yeah, I wanted to ask, when you have an and in an if statement, does the order in which you put those conditional statements matter
No.
in terms of time to run? I mean, obviously not for this, but in general.
Oh, I see what you mean. So whether if there was a more I mean, strictly speaking, yeah. So if you got, so I see what you're saying. If you had, if the first condition, you can see that that's not true, therefore there's no point, it's not going to check the rest of it. I can't imagine there being, you'd have to have an incredibly complicated conditional statement that would make that worth worrying about, and I can't imagine a situation where that would be the case computationally.
Okay.
So no, it doesn't matter, I think, realistically. Okay, so that's one. Let me just run that. So I'll just put in some numbers. Make sure I've got some odd ones in there as well. Okay, so there's a list of 10 numbers, but I've only got 5 back because the list comprehension has only returned things that are less than 100. So 102 is gone, although that would have failed both conditions anyway, as would 100, and it's only given me the odd numbers that are less than 100. And then finally for task 3, anybody spot the reference, by the way, out of interest?
Well, it's lost, isn't it?
It is indeed, yes. There's always a few of us that get the reference. If you want to save yourself 6 years of watching Lost, that's the summary, and it makes about as much sense as watching Lost, as much as I love it. So yes, you've crashed on a mysterious island, and you found these cave drawings that have numbers associated with surnames. You decide to write some Python code that will store the entries in a dictionary called candidates. And basically you've got a little piece of code that somebody types in the number and you want it to return, print out the corresponding surname. That's basically what it is. If the number doesn't exist, it'll ask them to input again, and you want it to keep doing this until the user types -1, which means they want to leave the system. Okay, so most of this has to go into a while loop, and most of it will go into, I remember I showed you how to do an infinite loop, a deliberate infinite loop, and the easiest way to do that is just use while true, because true is always true, therefore that automatically creates an infinite loop that will just keep going forevermore. But before I go into the loop, I do need to set up my list of candidates. I only want to do that once, so I've got my my dictionary of candidates. Remember, I use my curly brackets for a dictionary, and then I've got a set of 6 key value pairs, with the key being a number and the value being a string. Okay. So then in my infinite loop, each time, this is the thing that I want to keep repeating. So I need the user to input a candidate number or -1 to exit. It's the first thing I need to do. I need to remember to cast that as an integer because these are stored as integers up here in the keys. If you don't do that, then it'll be read in as a string, and that the string 4 Python will not see as being the same as the number 4. It does not see those. They're different things. There's a number 4 and there's a string which contains the symbol 4. Those are different in Python terms. Okay, so you cast it as an integer. Then we need to do a check on it. What you might, I did see one of the groups actually do this, which makes a lot more sense. Actually, you might want to first check if the selected candidate is -1, because at that point you don't need to do anything else. So that's more computationally efficient. But I haven't done that. So I'm first checking here to see if the number they put in, the candidate number, is in the dictionary of candidates. Now, I was a little bit devious here because I did show you how to do this. And I didn't, but you may not have noticed, so you have to be listening carefully. So earlier I talked about using the in keyword for lists, and I mentioned that you can use this for any iterable object, including sets and tuples and also dictionaries. So as well as lists, and a lot of the stuff you can do with lists, you can also do with the other iterable objects as well. So you can use this in keyword, which basically just says, if whatever they've put in is in this iterable object, in this case a dictionary, and in a dictionary it'll look through, because the lookup here is the key, so it'll automatically do that for you. So if it is in there, then it'll print the selected candidate by looking up in candidates and passing in as the index the key, remember in a dictionary, at the selected candidate. So if we type in 8, that will look up the corresponding value for 8, which is Alan. Then I check to see if they put in -1. If they didn't put in a valid number that's in here, then maybe it's a -1, in which case I will print goodbye and I will break to get out of this infinite loop. If they didn't put in one of the numbers that are in here, or if they didn't put in -1, if neither of those things happened, then the only other possibility is they put in a number which doesn't relate to a candidate, so I print no such candidate, and because we're in an infinite loop, we go back round to the start again. So we keep on doing it until they type in -1. That's the only point at which we can break out of that infinite loop. And that's quite a nice demo of some of the ways in which you might want to use an infinite loop, where you're constantly getting in input from the user until they tell you they've finished inputting, essentially. Okay, the other thing I was going to mention before we move on, and this came up in one of the sessions, and I always forget this usually comes up at least once a year, usually near the start, and it's good that it does, because it's worth mentioning. So let me go over to Spider. Now, I mentioned earlier briefly that there were certain things you can't name variables and other things that you name. At the moment, you're just naming variables and lists and things like that. There's certain things that are known as reserved keywords within Python, and that's because they're already used for something else. But I also mentioned right at the start of the day that Python is kind of very loose, and it lets you do all sorts of things. And one of the things it lets you do is to use those keywords. And in using those keywords, you can accidentally overwrite bits of Python. So if, for example, I've got an integer variable and I decide, and I'm not going to do this, but let's say I decide to call it int and put in 48, call my variable int, and I've assigned it a value of 48. Now, if I were to run that, it would indeed store a variable called int, and it would be an integer with a value of 48. The only problem is that in doing so, it will overwrite the definition of an integer object in Python. So then Python no longer remembers what an integer is. So if you then try and deal with casting a string to an integer, for example, it'll say, I don't know what you're talking about. This int thing is just a variable with a value of 48. What are you talking about? So be very careful with that. Now, you can undo it. Fortunately, Python is very easy to undo these things by essentially restarting your kernel, and that will flush the memory. But be warned, because Python does let you do stuff like this, and it's got a few restrictions, but not many. And so you could accidentally end up overwriting keywords, and particularly when you're new to coding, you can end up calling something like int, and thinking that's a perfectly valid name for your variable that's an integer, when it's not. So always try and be careful. Now, if you're in something like Spider or another IDE like that, if it comes up in well, it's orange on mine, but depends on your color scheme, you can see it's come up as a keyword as well when I've typed that. If I were to call it my int, it remains white and there's nothing appears. So be very careful about stuff like that, because you can overwrite fundamental definitions in Python, and then you won't know about it for quite some time until you go to use it, and then you'll discover a problem. And trying to then debug that problem may be difficult, because it won't say, oh, it's because I used to know about this thing called an integer and you then overwrote it. It won't do that. It'll just say, don't know how to do that with an int, and you'll scratch your head thinking I must have done something wrong. So just be warned. Now, Elliot's very usefully put in a little link here on the HSMA Common Room channel about reserved keywords. Worth checking that out. So do have a look at that. You'll get used to them. Trouble is, I can kind of forget about them because I've been coding for so long that my brain won't let me do things like that. And you will get to that stage too. But when you're starting out, you can accidentally do stuff. But the good thing about Python is it allows you to undo stuff. So it's very difficult to permanently break stuff in Python. Okay, let's continue. Where are we? We've done that. We're up to here. So let's now talk about libraries and imports. So you'll hear the concept of libraries and importing packages come up quite a lot when you're coding. Now, libraries are basically, oh, it's the gardener. Sorry, I thought my computer was about to blow up. Libraries are basically collections of functions that have been written by, well, could be other people, might be by yourself at a different time. But basically, these are bundles of useful stuff that you may want to use elsewhere, or that other people can use elsewhere, so that you don't have to reinvent the wheel every time you write code. If somebody's already done something that generates a random choice from a list of values, there's no point you writing, which they have, and you'll see in a moment, there's no point you then writing code from scratch that does that. Somebody's already done it, so you can use that. Okay, and that's one of the beauties of modern coding, is that you can use this stuff that other people have done and adapt it as you need it. Now, you'll learn about functions next week when we get into the second Python session. You'll learn much more about functions and writing your own functions and calling functions and stuff like that. And you'll also learn a bit about, when we come on to the object-oriented programming, about writing your own packages that you can then import elsewhere. But for now, let's just go over the basics. So imagine that you need to import a library. There's a library of stuff that you think will be really useful. The first thing you need to do, if you're going to use that within your own code, is to import these libraries into your program. And you usually do that using import statements that are written at the start of your code. Okay, so conventionally they go right at the start. Now, you don't import everything just on the off chance you might need it. You only import things that you are definitely going to need. So the way you tend to do that is, if you realize in the code, oh, actually I need to do this, I could do with that bit from that library, then you tend to import, well, probably not even that library, if you just need a bit of it. And we'll see later in the course that you can just import bits from a library. You can just say, well, I just need that function. I don't need that entire library. I just need that function from that library. But in some cases, like when we come on to SymPy, you'll import the whole thing because you're using the whole package. But we write these little import statements, and they always come at the start of your code, So in this example here, we've imported two libraries, one called math, which imports the math library, and one called random, which imports the random library. So I'm going to talk just very briefly about the random library for two reasons. First, it's a really, really useful one, and I'll explain why in a moment. But secondly, you're about to use it in the next exercise. So two good reasons to talk about it. So the random library basically contains a lot of useful functions that allow us to generate stochasticity within our models or within our code. Now, that's really important when we're doing modeling, because typically the models we build are stochastic models. In other words, they have an element of randomness about them. And if you're thinking, why do they have an element of randomness? Well, think back to last week in our very first session, and we talked about distributions. Now, you remember that we said that we use distributions in modeling to capture variability within a real world system, because it's no point putting in into our model that patients arrive every 5 minutes and they spend exactly 5 minutes with a nurse, and the world doesn't work like that. We use averages, but we still put some randomness around that. So we use distributions as a way of capturing that real world variability. Essentially, they're probability profiles. They're a way of saying, okay, there's a 50% chance that this patient, any patient coming in, will spend 7 minutes with the nurse, but there's a 20% chance they'll spend 9 minutes, and there's a 1% chance that they'll spend 30 minutes with the nurse. Okay, so it captures that real world variability. And remember, we talked about typically we use a certain name distributions. These are distributions that have a particular shape, and we can specify and set them up using various parameters that define that distribution. And some of the common ones that you will tend to use, probably the two most common, just as a reminder for discrete event simulation modeling, are the exponential distribution, and for log normal, the log normal distribution. Exponential distribution you tend to use to randomly sample the inter-arrival time, the time between this patient arriving and the next patient arriving into a service. The log normal distribution you tend to use for process times, to sample how long this patient is going to spend being registered, how long this patient's going to spend with a nurse, etc. Okay. However, I also gave you the advice, which I think is useful for this kind of thing, that at the start, because the log normal distribution is a bit more complicated, when you first build a model, a discrete event simulation model, it's a good tip just to put everything as an exponential distribution. Okay, because the exponential distribution, you just specify essentially one parameter, the mean. And that makes it easy to fine tune and adjust and go back to your stakeholders. Because you can say, well, we're estimating they're coming in about every 3 minutes. And if they say, oh, no, actually, it's about 5 minutes, you can just change a number there. It's much easier than dealing with the log normal, where it's a bit more fiddly to do that kind of thing. Okay, so you tend to start with exponential for everything, and then once you're happy, try out the log normal for your process times, and that will tend to work quite nicely. So you'll get lots of experience when we come on to the SymPy stuff in a few weeks, where you'll sample from exponential distributions in SymPy. Anyway, that's why we're using it. That's why the random library you'll find is particularly useful, but it's also more widely useful for Python coding as well. So once we've imported the library, we can now use its functionality. And here, by using the statement import random, that means import the whole library, so I can get anything from random. Now, remember we talked about earlier, if we using this sort of class object notation, when we call a function for the library, we need to use the format, the name of the library, followed by a dot, followed by the name of the function or the name of the attribute. In the same way, when we come onto the object-oriented programming, you'll see that you give a class name dot and then name of attribute or name of method. In the same way earlier, we looked at the lists and we said a list is a list. Your list is a list object, an instance of the list class, and therefore to access various methods of the list class, we use the dot notation. We're doing the same thing here. We're importing something called random, and I can get the methods of random by using the dot notation and saying random dot and then the name of the function I want in this case. So there's a few key ones that I'll flag up here. There are absolutely hundreds of these, and you can read the documentation if you want to know about all of them. But here are some of the key ones that you'll find useful right off the bat. So random.random, in other words, the random function of the random library, which I don't think is a great name, actually, calling it random, because random can mean anything. But basically, random.random will generate a random number between 0 and 1, sampled from a uniform distribution. So if I go back, we talked briefly about the uniform distribution. The uniform distribution basically says there's an equal chance of any of the values being picked, unlike, say, an exponential distribution where it's much more highly weighted towards the lower values. So there's an equal chance of anything being picked, and you'll find this is really useful, particularly for conditional logic, and you'll discover how shortly. There's also a method in the random library called randint, which basically generates a random integer, a whole number, within a range that you specify. So if I put randint 110, that'll randomly pick a number between 1 and 10. Here's the kicker. After spending all morning saying it always includes the bottom value and not the top, randint includes both, just to confuse you. So if you put randint 1 and 10, it can pick at the value of 10. So watch out for stuff like that in Python, because you'll get examples where that you think you've found a good rule of thumb, and actually then you find something that completely ignores it. So there we are. Such is the world. So randint 1 and 10 would randomly pick a whole number between 1 and 10 inclusive. Then imagine we want to we have a list, and we want to randomly pick one of the things from that list. So I've got a list here of 3 names, and I can use the random.choice and then pass in my list, and that will randomly select an element from that list. Again, that will work with all of these things. They'll work with other iterable objects as well as lists. So it'll work with dictionaries, sets, tuples, etc. as well. Okay, right, back over to you now. So let's see where we are. Okay, we're pretty much back on track. So what you're going to do now, you're going to go back into your groups, and then this is a real group exercise that you're going to be doing. So you're going to be working on this together in your groups. Now, you're going to compete now against 4-year-old Dan. Okay, so you remember last week in the Principles of Programming, I told you that I had my very first computer, my Atari 800 XL, back in 1985 when I was 4 years old, and that's when I started coding. You are this afternoon in your groups going to challenge 4-year-old me, and you're going to see if you can write a better version of my very first computer program. Okay, so when I was 4, on my fantastic Atari 800 XL in BASIC, I wrote my first program in which the computer would randomly pick a whole number between 1 and 100, and the user basically had 10 chances to guess what the number was. Every time they guessed the number, the computer would tell them either the number was too low or too high or correct. And if the user used up all of their 10 chances without getting the number, they were told you lose, and the game would end. Now, I've now taught you enough today that you are able to write this program in Python. But because you are not 4 years old, I'm going to challenge you to add on some bells and whistles that I didn't have back when I wrote my first computer program. So as well as this basic functionality up here, I also want you to implement a score which will start at 1,000 and which reduces by 100 for every unsuccessful guess, and then which is displayed, the score is displayed if the user wins. I want you to store the user's guesses in a list, and they get printed. All of the list of guesses get printed once the game ends. I want you to get it so that the game asks the player if they want to play again once the game's ended. And after each game, the player's score should be checked against a current high score, which defaults to 0 when it's first run. And if the last score is higher than the current high score, that would replace the high score. Okay. And then if you manage to do all of that as well in the time, then feel free to add some bells and whistles of your own choosing. So I'm going to give you about 40 minutes plus a 10-minute break. Let's see if that brings us back to about on target. Yeah, ish. Okay, so let's do that. Just having a look. Where are we now? Okay, let's go to about 3:35. We'll resume. So take a 5-minute break somewhere in there as well. So I'll give you till 3:35 to have a go at this. Okay. If you're all getting on well, I'll bring us back a little bit sooner. But I'll keep an eye on what you're doing. So have a go, work on it as a group. One of you share your screen, and then all discuss how you're gonna build this. Okay, have fun. I'll open up the breakout rooms and have a go at outsmarting 4-year-old Dan.
Being recorded.
Okay, hi everyone. I managed to float around most of the groups, I think, and most of you were pretty much there with it. I will whiz through the solutions. I want to get on to the final exercise, but I'll just quickly whiz through it. But again, the solution will be uploaded, or it's a solution. There's different ways you could have approached this. But I think most of you were getting the core elements. As ever with stuff like this, where a few of the groups were struggling, where you try and break things down. So I gave you a lot of stuff all at once, where you had to think about loops within loops, essentially, where they may keep playing. If you're struggling to think about that, think, okay, well, let's just code it so that it plays one game first of all, and now let's gradually add the bits to that, and then we'll build it up, and now you can play lots of games and the user can select. So that's quite a handy way. I still find it quite useful to think about breaking things down if you've got sort of an overwhelming coding objective. So let me share my screen, and where's the solution? Here it is. Okay, so I'm just going to whiz through this fairly quickly, but as I say, the full solution I will upload, and there's different ways, slightly different ways you may have done this, but first of all, I import my random library, then I set a high score of 0 as my default high score, and I've got a continue play variable value, just a boolean that's set to true. You may have done this just as a while true loop. That's also fine. It's just some way to get you to continue playing the game whilst a certain condition is true. I've got a little friendly message that says I'm thinking of a number, can you guess what it is? The computer then randomly generates a number between 1 and 100, a whole number, and I've got a few little bells and whistles here. I've said that there are 10 guesses. That allows me to easily change that, so I could change it to 20 if I wanted. I set a little boolean variable called correctly guessed, which I've defaulted to false because at the moment they haven't correctly guessed what it is. I've got my score set to be 1000 at the start, and then I've got a list of guesses ready to add the guesses the user makes. So within this while loop, I've then got a for loop, and basically this represents one round of the game. So for I've used I here for I in range. You may have just hard coded 10. I suspect most of you will have done that, but I've set it to this variable value, which just allows me to change it here if I wanted. It's the same thing. So do this essentially 10 times. I put in a little message, print this is guess number, whatever it is, and ask the user to input their guess. I'm going to add that guess to the list of guesses, and then I'm going to check to see whether their guess was right. If it was, then brilliant, fantastic, well done. I'll tell them what they scored. I'll show them their list of guesses, and then I can select correctly guessed to true, and I can break. Now this is where it gets a little bit more complicated. So you can break out of a for loop or a while loop. If I break here, that will break me out of the for loop, but I'll still be in the while loop. Okay, so you need to make sure that that you're breaking out of the correct loop. So it can get a little bit difficult as you start nesting loops. But that's what we want here. We want it to break out of the for loop because this particular round of the game is over. I've correctly guessed. If I didn't correctly guess, though, I need to check whether it's less than my guess was less than the computer's number, or whether it was too high. And in both of those cases, I'm going to decrement the score by 100. Some of you may have written score equals score minus 100. That's fine. Remember, I showed you this little bit of shorthand. Score minus equal 100 says the same thing, basically. After that round is complete, so if we get down here, we've either made 10 guesses and we didn't get it, or we made a number of guesses and we got it correct at some point. So we come down to this point here. Now I can check if I did correctly guess or not. Okay, so if I did correctly guess, that would have been set to true, and I'll never see this message. But if I didn't, that will never get set to true, and so this will remain as false, which is what I said it at the start up here. And so this message I'll then see, you lose, here are your guesses. And then I make a check here to see if my score, whatever score, is greater than the high score, which defaults to 0. If so, then I'll print that new high score, and I'll set that score to be the new high score. Then I just allow the user to choose to play again or not. I think I've just allowed them to type Y to play again. If they select basically anything that isn't Y, then I'll set continue play to false, which will break out of the while loop. Okay, so that's very quickly sort of the basics. I think most of you had the fundamentals there. But I'd advise you to have, if you didn't manage to get through all of it, have a look at the solution once it's up. And as I say, this is not the definitive answer, but this will, if there's a few bits where you're a bit confused, hopefully this will show you the right direction. Okay, we're going to move into the final exercise of the day now, and it is time for the annual HSMA group coding competition. So it's become a bit of a tradition over the last few years that after the first training day in Python, we set you off in your groups in order to come up with an interesting program based on what you've learned. So let's think about what you've learned today. You've learned about how to print to the display. You've learned about variables and how to cast variables. You've learned about getting inputs from the user, about comments, about mathematical operators, conditional logic, loops, both for and while loops, lists and list comprehensions, and dictionaries as well, libraries and importing stuff from other libraries, and specifically the random library you've learned a little bit about. So what I want you to do now in your groups, you're going to go back into your groups, and I want you to design and build a computer program that uses some or all of these things. It doesn't have to use everything, but uses aspects of what you've learned today. The program can do absolutely anything you like. Okay, so you can choose whatever you like for your program to do. Just be creative, come up with an idea. You're going to have a little bit less time, so we're going to come back just after 4:15. Each group is going to get 1 or 2 minutes to present what you've come up with in your groups, and then Elliot is going to judge the best. He doesn't know this yet, but he's going to judge what he thinks is the best entry, and that group will then be crowned the group coding competition winner for HSMA 5. Okay, before you get too excited, there is no tangible prize, although you will have a little celebration on Slack, which I'll share later. Okay, so I'm going to put you back into your groups. Come up with anything you like. So throw around some ideas, and then one of you share your screen and start coding together in a group. So one of you do the coding and others sort of throw in ideas. So pick whoever's most comfortable, confident at this stage, probably to do the coding now, and throw something together. So you've got just over half an hour to come up with any program you like, but it can only use the things you've learned about today. Okay, right. I will stop there and we will float around. And I look forward to seeing your entries in just over 30 minutes. Make sure you nominate somebody to present it as well, and Elliot will be the judge and decide who wins the prestigious award this year. Great, right, let's open the rooms.
This meeting is being recorded.
Okay, welcome back everyone. So I managed to get around to I think all of the groups, even though I was I only managed to peek into a couple at the end, and there's some really good stuff that I saw, some really interesting ideas, a few groups interestingly trying similar things as well, which was quite interesting. So what's going to happen now is I'm going to hand over to each of you in turn. So the nominated spokesperson from each group is going to have just 1 minute to share your screen and just talk us through briefly what you've designed. If you can show it running, great. But if not, talk us through what you were trying to achieve. Elliot's going to keep some notes, and then after we've seen all 10, Elliot will decide which one is going to be crowned the winner. But I have to say, before all that, fantastic, well done to all of you, regardless, because when you consider that for most of you, you'd never even, well, in fact, for quite a few, you'd never coded at all before today, but certainly for most of you, I'd never coded in Python before today. So you've only been doing this for a few hours, really. So to be coming up with this kind of code is brilliant. So you should give yourselves a pat on the back. And as I say, all of this stuff will get easier with practice. But let's see what you've come up with. So we'll go through them in order. So we'll start with Acorn Archimedes. Do you want to share your screen and show us what you did?
Hi, I'll be presenting. And Ben very kindly typed and coded everything for us, so he'll be sharing screen. So this is a proof of concept game, Guess the Animal. And we have, the idea of the game is that we have picked an animal, and the user has to guess what it is. If they get the guess wrong initially, the game will give them some feedback and say there is an attribute to this animal, such as this animal has this many number of legs, and asks the user to guess again. And it keeps going until all the attributes have been used, and then it says, yeah, that's when the game ends, or if the game also can end if they guess it correctly. Yeah, and here's a demonstration. So if it's not within a dictionary, there's just an else if statement saying it's not in a dictionary for now, as we haven't made an exhaustive list. And so yeah, it's gone through 2 attributes there. It has 4 legs and it does not have feathers. It's not quite phrased correctly, but it's as good as we could do in 20 minutes. So thank you.
Thank you. Well, I think my cat has false feathers, so I'll let you off that. Fantastic. No, really creative. I like that. I like that a lot. Brilliant. Thank you very much. Okay. Amiga 500, you're up next.
Hi, everyone. We thought we'd create a race simulator. So yeah, we declared a couple of variables at the top of the shop. So it's a target of just an arbitrary 10 steps. And we basically declared the start position for each position, for each player. So we're playing against the computer. And basically we initiate a command to roll the dice. That dice roll comes back with a random dice roll, and then basically we knock the dice roll from the target, and that happens until the player gets to the target, and then we compare again the progress against the computer. So as you can probably guess, the end state isn't quite worked out just yet. But that's all we could do in the time. We're also looking at appending the dice rolls to a list, which we didn't quite get to, but then we could kind of work out some stats then on the number of turns it took to get to the required number of steps. So I can just give this a real quick demonstration. We can enter a name and then press R to roll the dice. So you see there, we get the roll of 4, it gives us our progress, so the computer has a go, and we do that until, oh, great, I won. So yeah, work in progress, but hopefully you can see kind of what we were trying to get to.
Fantastic, thank you very much. No, that's again really creative. I like that. A nice use of random numbers, and I like your thinking about potentially extending that and looking at the almost the distribution as well of that. So brilliant, fantastic. Thank you very much. Okay, so next up we've got Amstrad CPC.
Hello. Can you guys see my screen?
Yeah, that's okay.
Which screen is it showing? Is it showing the spider script? Sorry.
No, you're on Slack at the moment.
Oh, here we go.
That's
There
it.
we go. So we've kind of adapted the last bit of programming that we were doing with you to make a little hangman game. So we've chosen a list of words and it will give you a random word, but it won't tell you what it is. And then you have 10 guesses and it will tell you whether or not your guess is correct or incorrect. And then at the end of your 10 guesses, you get to guess the full word. And then it asks you if you want to play again. Oh, let me just stop this and I'll run it. So if we guess, so A is in there, C is in there, I is not, P is not, C is not, H is. So we know there that we've got 3 letters. So I'll just go through some random letters. So we know from here we've got an A, a T, and an H. So it's probably hat. And then it says you win. If we had more time, we would have added a thing to let the user know at which point in the string that character is, and also got the game to skip to the final guess once you guess 3 correct letters. Yeah, that's our game.
Fantastic, thank you. No, excellent, really ambitious as well to do that within basically half an hour. So fantastic, no, really nice. Okay, Apple Macintosh, you're up next.
Okay, let me just share my screen. Right, hopefully can you see my spider window?
Yeah, that's coming through okay.
Okay, so we also went for another little game, this time rock, paper, scissors. So we have a list of possible choices, we just, to make it a bit easier, it's R, P and S. So the computer makes a random choice from that list. And then the user is prompted to make their selection based on R, P, S. And then we've got big if statements to check whether that's a draw or whether the computer is winning or else the user is winning. So I will just run it and hopefully that will work. So user, let's choose rock. And in this case, the computer wins and it tells us the computer selected P, paper. So they beat us. And so, yeah, we were thinking about obviously going on and doing a bit more, adding some loops to kind of say, do you want to play again and other things? But this was as far as we managed to get.
Fantastic, thank you very much. No, again, a really creative idea doing rock, paper, scissors, and again, using the random library in a creative way. I like that. Thank you, fantastic. Okay, so Atari 800, you're all next up.
I can share a screen and happy to chat through. If anybody else from my team would like to chat through, that's totally fine as well. So if you can see it okay, this is the unique game of rock, paper, scissors. And we start off by printing, welcome to rock, paper, scissors, game of skill, not chance, obviously. And similar to the last team, we create a list of elements, these ones that we've numbered, and then we create a while loop to try and create a continuous game where we compare the input from the user to the input from the computer. And for each go, it says, select rock, paper, scissors. Okay, I'll select rock and I've lost. And then hopefully in future, we'd be able to choose from an index list, whether that was rock, paper, scissors, not just 1, 2, 3. And then we could play again and continue that way. So yeah, still work in progress. In future, we'd like to index to rock, paper, scissors and maybe add a scorecard as well.
Fantastic, thank you. Another rock, paper, scissors. I just crossed my mind. I'd love to see you go back once we come into the machine learning training. I could imagine a nice little building a simple AI that then tries to work out what you're likely to put based on your history of selecting things, and then put it that could make a neat little piece of code. That cool, fantastic. Atari ST, you're next up.
Yeah, hi. Share my screen a minute. So we had a play around with the Beautiful Soup library. It's a web scraping package. So the idea is you promptly use a URL, an input. We've also got a default input in case they don't provide one. They can just provide the default text, which would default to the Elvis Presley Wikipedia page. The second prompt will ask them for a set of keywords they want to search. So it allows you to do a frequency count of those words. This loop down here will then append those keywords to the dictionary we've got here, and it should give them a total count of those words. Give it a try. Yeah, we should get a dictionary then with the count of words for that web page. Didn't quite get it finished, but it works sort of.
Fantastic. I really like that. That's you'll enjoy the natural language processing stuff, I think, when we come on to that in December, just before Christmas, when we explore some of that, and you'll be able to see how you can do then some fancy stuff with some of that. And so fantastic, brilliant. Thank you very much. BBC Micro, you're next up.
Hi there. That says, bear with me 1 second. Cool. Can you see my screen?
Yeah, that's okay.
Ah, cool. So yeah, we've got a pretty simple take of an old game called Play Your Cards Right. Which I'm sort of reliably informed was, yeah, I've got a vague memory of it. Yeah, Bruce Forsyth. So this is our attempt, just a simplified version of it. There's probably, if you had time, would have expanded on a few things here. So the idea is obviously we use the random library, sorry, and generate some random integers between 1 and 20. We generate 6 of them to keep it short, and the user has 6 goes to guess the next number. So just to give an overview of the game, there's the first number, then the user guesses whether the next number is higher or lower. And if they guess correctly, then the game continues, they're correct. And if they correct all 6 or 5 goals correct, then they win. And if not, they lose. So that's the game. Let's play. So you can see it's playing here, and it's called Play Your Cards Right, very simply. It gives you the current number, the starting point 13, and it asks you higher or lower. So the next, so it's between 1 and 20, likely to be lower. Oh, that ended quickly. That ended quite quickly. I lost. I'll give it one more go because I want to proceed past 1. 11, higher, correct. So you get correct, and the current number now is 15, so we'll guess lower. Correct, 5, higher, correct. 5 again, that's something else we want to die. Now it gives the same number. Higher, 10, lower, correct, you're the winner. So yeah, very simple take on Play Your Cards Right. We would have added, if you had more time, an option for the user to have a different random number at that integer, the index of the list, maybe change the next number if they're quite sure. And a few other things as well, probably if you had time, but that's as far as we got.
Brilliant. No, thank you. Again, a creative one. I mean, you nearly lost me when you said an old game called Play Your Cards Right. So thanks for making me feel nice and old. But
apologies.
I'm not judging, so I was just humming the Play Your Cards Right theme tune in my head as you were talking. But excellent. No, really, really creative. Fantastic. Okay, 3 more left. So Commodore 64, you're up next.
so you can see my screen. We tried to recreate the game of Yahtzee, so a simple dice throwing game. So user input, like we saw before, asked to play the game. So if I just run this, it'll ask for your name, and are you ready to play a game? I'll say yes. Then it'll give me a simulated dice score of 1, 5, 2, 2, and 3. It'll give me the sum for that. And the next steps would have been for us to find the most common number in the list, and then apply a score based on that, which I vaguely remember is how Yahtzee works. And those would have been our next steps.
Fantastic. Thank you again. A really creative use of the random library. I like that. And yeah, you could imagine expanding that really nicely. Again, using some of the lister methods, etc., that you've seen and which we'll show you as well. Fantastic. Okay, 2 left. So IBM PC, you're next up.
Hi. If Jane will share her screen, she kindly coded this for us. I'll talk you through it.
Okay, can you see it?
Yeah.
Yeah. So basically, we replicated the game of Pontoon, or 21, as some people might know it. We started with a list of 13 numbers for the 13 different cards, 11 for Jack, 12 for Queen, and 13 for King, which we just put in numbers. Then we dealt 2 cards using a random number to pick one of the cards from the list. Went round a for loop twice and totted up the points. And then once we'd got the score, we then asked the user if they wanted to stick or twist, and went round a while loop until they decided to stick. If they were over 21, then they bust and broke out of the loop. And then at the end, we then checked the number of points. If they were over 21, then we printed they were bust. We counted the cards. If they had 5 cards, we had a 5-card trick. And if they had 21 points with 2 cards, then they had a pontoon. And that was as far as we got. We would have had all the cards in a deck and removed them as the cards were dealt, but we didn't have time to do that. Or we would have had 2 players playing against each other and totted up their scores and see who won the game. But that would have taken too long.
Fantastic. No, thank you again. Another really creative. I think this is great what I'm seeing, and I think you're all going to love the coding clubs that we're putting on, because this is basically, you get to do this but at a larger scale for a couple hours and get to do some fun stuff and actually really get into be creative, but explore some of this stuff in more detail. So fantastic. No, right, okay, last one, ZX Spectrum.
Cool. Let me just share my screen. I was trying to quickly do one last final thing, but I didn't quite get there. So, can you see my screen? It should be Spider.
Yep.
Cool. So we decided to go for a Caesar cipher, which is where you offset the alphabet by a certain number. So we've sort of created a standard alphabet library, and then we can, using an offset number, we can offset that and put a message in. So we run that, give us an option whether we want to encrypt or decrypt. So we want to encrypt hello world and offset by 3, for example, which should give us a weird string. Then we can copy that and decrypt. And we want the message to be the same thing, and the offset is 3. It should go back to hello world. I was just trying to develop a thing where it generates a random integer to offset each time, and when you decrypt, it decrypts using that last saved integer, but I'm about 90% of the way there.
Fantastic. No, thank you. That's really interesting. I've never seen a group come up with something like that before. So that's yeah, really interesting. It's a neat little thing. I think I'll have to use that to write messages to my manager, just so I can encrypt it. Cool, excellent. Well, there were 10 excellent programs there. Really impressed, as I always am at this stage. And again, just to remind yourselves, you started coding at, well, not even 9:30 this morning. I started talking about coding. You started coding really about 10:30, 11 o'clock. and it's only 4:30 now, and you've come up with some fantastic stuff. So really well done to all of you. But I am going to hand over to Elliot now, who's been making notes throughout this, and will make a decision about who is this year's prestigious winner of a non-existent award.
Thank you very much, Dan. Hopefully you can hear me okay. My speaker and my microphone isn't great. So okay?
No, that's fine. Yeah, we can hear you.
Cool. I just want to echo what Dan said. You know, it's fantastic. I'm really, really impressed. It's apparent that possibly some groups have had people maybe who coded before, you know, looking at things, you know, beautiful soup. Maybe wasn't covered today. But all things considered, I'm looking at what Dan has taught you today. I think Amstrad CPC would be the winners for utilisation of the things we talked about. But as I say, everyone did a superb job, and to come up with something in that space of time when you're working in a group as well, it is a real challenge, and I'm blown away, quite frankly, with everyone. So well done to the team of Amstrad CPC, but everyone's a winner as far as I'm concerned today.
Fantastic. Thank you, Elliot. Yeah, absolutely. Completely agree with that. Well done, Amstrad CPC. I was tempted to say you're hired. That's just such a terrible joke, but you know, that's what HSMA is all about. Fantastic. No, well done, and well done everyone, because some fantastic stuff there. And I would encourage you as well to you know, some of you had stuff that you wanted to do, finish that off in your intern and bat it around your Slack channels, and finish it off. And once you've got a sort of finished thing, share it on Slack, put it on one of the public Slack channels, let other people see what you've done. It's great at this stage particularly to be you know, sharing code and sharing what you've been doing and practicing, and hopefully you've got a taste of that this afternoon, where you've been getting much more sort of hands-on experience of the coding. So my overall message is well done today. This stuff will come, as I say, it's the first day you've been coding in Python, really, and you've essentially got 6 months of this throughout the training, where you will be practicing coding in Python throughout the entire training. All of it is virtually all of it is Python based. So this will come to you, but the more you practice, the better this will be. So try and fit in before next week. See if you can get a little 5-10 minutes here and there, just write a little simple piece of code, just keep practicing it, and you'll find that it'll help. Maybe, you know, share it on your peer support group and say, oh, this isn't working, or look what I did, and encourage others to do the same. And as I say, I'd encourage you to come along to the coding clubs where you can, where you'll get to do basically more of what you've just done in the last half an hour, but over a longer period, where you can create some really, really great stuff. Okay, so we'll stop there. Next week, we'll carry on with the Python training, where we get into session 2. We'll be talking about things like functions and various other aspects of Python training. So you've covered the kind of fundamentals today of Python code, but next week we'll start to dip into some of the other stuff as well. So just reminding myself, I think we've got, so we'll be looking at exception handling as well. So what you do about errors and handling errors, a bit about file reading and writing. And then in the afternoon we'll be covering NumPy and pandas, which are 2 very important packages for scientific computing that you'll be using throughout. Fantastic. So thank you everyone for coming along today. Hope you've enjoyed it, and see you next week, and keep coding.
Thank you.
Thanks, Ben.
Thanks. Bye.
Thanks everyone. Bye now.